Hello my dear friends, ಎಲ್ರಿಗೂ ನಮಸ್ಕಾರ. Myself ಕೋಡಮ್ ನವೀನ್ ಕುಮಾರ್, ನಿಮ್ಮ ಕೆಮಿಸ್ಟ್ರಿ ಫ್ಯಾಕಲ್ಟಿ. I welcome back you all to this incredible platform Physics Wallah. ಈಗ ನಾನು ಇವತ್ತು ನಿಮ್ಮ ಮುಂದೆ ಬಂದಿದ್ದೀನಿ with the board 2 marks question. ನಿಮ್ಮ PUC 2 ಅಲ್ಲಿ 2 marks questions ಇರುತ್ತಲ್ವಾ ಬೋರ್ಡ್ ಅಲ್ಲಿ, that all 2 marks question that I have brought today. ಈಗ these 2 marks questions are very important. Now it will be helpful for your board to get ಎಷ್ಟು marks ನಿಮಗೆ out of the out marks ಬೇಕಲ್ವಾ in the part 2 or else in the 2 marks question. ಈಗ 2 marks questions, ಈಗ 2 marks questions ಕೊಟ್ಟಿದ್ದೀರ ಅಂದ್ರೆ by seeing this video, by seeing the video, you will attempt all the 2 marks questions, all the 2 marks questions which they have given in your board. ಈಗ ನೀವು ಏನು ಮಾಡಬೇಕಂದ್ರೆ don't see the video very fastly. ಈಗ ನಾನು ಈಗ ಫಸ್ಟ್ ಆಲ್ರೆಡಿ ಇಫ್ ಯು ಹ್ಯಾವ್ ಡಿಡ್ ದ ರಿವಿಷನ್, ಈಗ ಏನು ಮಾಡಂದ್ರೆ ಈಗ ನಾವು ಫಸ್ಟ್ ಬೈ ಸೀಯಿಂಗ್ ದ ಕ್ವಶನ್ ಜಸ್ಟ್ ಟ್ರೈ ಟು ಏನು ಮಾಡಿ ಅಂದ್ರೆ ಜಸ್ಟ್ ಟ್ರೈ ಟು ಸಾಲ್ವ್ ದಟ್ ಕ್ವಶನ್ ಆರ್ ರೈಟ್ ದಟ್ ಕ್ವಶನ್. ಇಫ್ ಈಗ ಆ ಕ್ವಶನ್ ನಿಮಗೆ ಗೊತ್ತಿಲ್ಲ ಅಂದ್ರೆ then what you do then in how much fast we can understand that concept, how much fast we can write that question ಅಂತ I will explain you very ಕ್ಲಿಯರ್ ಆಗಿ ನಾನು ಎಕ್ಸ್ಪ್ಲೇನ್ ಮಾಡ್ತೀನಿ. ಈಗ ಮೊದಲನ ಏನು ಮಾಡಬೇಕಂದ್ರೆ see the conceptual question or conceptual videos. ಈಗ first solutions, next chemical kinetics, electrochemistry, then one by one the chapters will be coming. ಈಗ ಏನು ಮಾಡಬೇಕಂದ್ರೆ if you have not studied the theory, ಏನಾಗುತ್ತಂದ್ರೆ this will make you to difficult. ಯಾಕಂದ್ರೆ ನಾನು on the basis of what already you have studied the concept, then you have came here to solve the questions, and now that questions how much fast you can solve anta for that one I have brought this one. First what you do, see the which one total ಯಾವುದು total conceptual videos or else total theoretical videos you see. Then if you come, then it will be more understanding for you. Clear ಆಯ್ತಲ್ವಾ? Now ಈಗ let's start our session of ಯಾವುದು 2 marks questions in one shot. ಈಗ ಎಲ್ಲ ಕೆಮಿಸ್ಟ್ರಿ your second PUC board total 2 marks questions we are going to see. Now first question, state the Henry's law. ಈಗ ಸೊಲ್ಯೂಷನ್ ಅಲ್ಲಿ ಮೊದಲನೇ ಕ್ವಶನ್, ವಾಟ್ ಇಸ್ ದಟ್ Henry's law? ವಾಟ್ ಇಸ್ ದ ಮೀನಿಂಗ್ ಆಫ್ ದ Henry's law? Henry's law ಅಂದ್ರೆ ಏನಂದ್ರೆ, ಈಗ ಒಂದು ಲಿಕ್ವಿಡ್ ಅಲ್ಲಿ this is the liquid and we are having the gaseous with a different partial pressure. Okay, A gas and this is a B gas. Okay, E gas ಗೆ partial pressure ಬೇರೆ ಇರುತ್ತೆ, ಈಗ B gas ಗೆ partial pressure ಬೇರೆ ಇರುತ್ತಲ್ವಾ. Now by applying some pressure or some mass. Now when you apply some mass, ಏನಾಗುತ್ತೆ, the partial pressure of the gas, which is having higher partial pressure, the gas which is having the higher partial pressure will dissolve in the liquid. The gas that dissolve in the liquid, ಯಾವುದು gas will dissolve in the liquid very fastly? The gas which is having higher partial pressure. The gas which is having the higher partial pressure will dissolve in the liquid very fastly. That it was said by the Henry's law. What is the meaning of Henry's law? The solubility of the gas in the volume is directly proportional to the partial pressure of the gas. the partial pressure of the gas. This is the Henry's law. This is the Henry's law. Okay? The partial pressure of the gas. Clear aitalla? Next, why the aquatic species are more comfortable towards the respiration in cold water than the warm water? ಈಗ ಏನಾಗುತ್ತಂದ್ರೆ, if you increase the temperature, solubility is inversely proportional to the temperature. So if you increase the temperature ಏನಾಗುತ್ತೆ, solubility ಕಡಿಮೆ ಆಗುತ್ತಲ್ವಾ, then ಈಗ solubility ಕಡಿಮೆ ಆಗಿದೆ ಅಂದ್ರೆ, now water ಅಲ್ಲಿ, now aquatic species, now this is, let us assume this is a river. Now in this water at the normal temperature, now oxygen in the dissolved form alli irutalva. Now dissolved form of O2 will be present in the water. Now if you increase the temperature, what happen? Now solubility of the O2 which is present in the water, it will not be available. ಏನಾಗುತ್ತೆ, the O2 will not be dissolved in the water. ಅದಕ್ಕೋಸ್ಕರನೇ the aquatic species which is present in the water, it will be die. When we increase the temperature. Clear? Now you know, aquatic species are more comfortable towards the respiration of the cold water than in the warm water. Why? Now if we increase the temperature, solubility of gas decreases. Okay, done. ಎಷ್ಟು ಬರೆದ್ರೆ ಸಾಕು for the 2 marks questions ಅಲ್ವಾ. Next question ನೋಡೋಣ. Next question, give the reason the I value of the KCl is more than the benzoic acid in the benzene. This is very, very important. Now what is the meaning of the I? This is the Vanta factor alva. I, what is the value, what is the definition of the I? I is equal to number of moles of particles dissociated or associated by total number of moles initially. Now this is the I. Now illi nodi, KCl is the strong electrolyte alva. KCl is the strong electrolyte andre enu, it will be completely dissociate agutalva. It will be dissociate. KCl will be completely dissociate alva. Andre here it will dissociate to the K plus and the Cl minus. K plus matte Cl minus alva. Now initially KCl is to 1 mole. After it has been converted into dissociation, now ಎಷ್ಟು 1 plus 1 2 alva. Andre I value will be 2 by 1. For the KCl I value will be 2. But when it comes to the benzoic acid, in the benzene ಏನಾಗುತ್ತೆ ಅಂದ್ರೆ it will form the dimerization. Now ಈಗ 2 moles of benzoic acid, it will form the association. 2 moles of benzoic acid in the presence of benzene, ಏನಾಗುತ್ತೆ ಅಂದ್ರೆ it will form the only one single molecule. See, now this oxygen this oxygen is having the partial negative character, this hydrogen is having the partial positive character alva. Now here this will form the dimerization. Now this hydrogen it is having the partial positive, this oxygen is having the partial negative, and now this will form the dimerization. Now two moles of benzoic acid to give the only 1 mole of the compound. Clear? Now the I value will be 1 by 2. 1 by 2 ಅಂದ್ರೆ ಏನು 0.5. ಅದಕ್ಕೋಸ್ಕರನೇ I value of the KCl is more. ಯಾಕಂದ್ರೆ it is strong electrolyte, it will be dissociated into the 2 particles. ಅದಕ್ಕೋಸ್ಕರನೇ I value is 2. But the benzoic acid in the benzene, it will undergo the dimerization. Now I value for the benzoic acid is 0.5. ಅದಕ್ಕೋಸ್ಕರನೇ KCl is having the I. Clear? Next, write any two difference between the ideal gas and the non-ideal solution. Ideal solution and the non-ideal solution. Ideal solution ಅಂದ್ರೆ ಏನು? First, ideal solution. First we'll take the ideal solution. Now here we'll take the non-ideal solution. First, ideal solution ಅಂದ್ರೆ ಏನು? It obeys Raoult's law. It obeys the Raoult's law. Non-ideal solution, it does not obey the Raoult's law. It does not obey the Raoult's law. Now here partial pressure of A is equal to vapor pressure of A is equal to pure component of A into its mole fraction, or B, vapor pressure of B, solute or solvent, it will be pure component of B into its mole fraction of the B. It's obey the Raoult's law. This will not obey the Raoult's law. It will not obey the Raoult's law. Clear? Here delta H mixing is equal to 0. Delta V mixing is also equal to 0. ಇದರಲ್ಲಿ delta H mixing is not equal to 0. Delta V mixing is not equal to 0. Clear? 1, 2, 3. Clear? 1, 2, 3. This is for the 2 marks. ಈಗ 2 marks ಗೆ ಎಷ್ಟು ಬರೆದ್ರೆ ಸಾಕು. ಕ್ಲಿಯರ್ ಆಯ್ತಲ್ವಾ? ಓಕೆ, ನೆಕ್ಸ್ಟ್. Now next, what are the colligative property? In that colligative property, give the osmotic pressure and what is the isotonic solution. Now colligative property. ಈಗ colligative property ಅಂದ್ರೆ ಏನಂದ್ರೆ colligative properties ಇದರಲ್ಲಿ we are having the 4 type of the colligative properties ಅಲ್ವಾ. Now it will not depend upon the nature of the solute. It will depend upon the nature of the solute particles. Clear ಆಯ್ತಲ್ವಾ? Now here colligative properties which depend upon the number of solute particles, not on the nature of solute. Clear? Colligative properties which depend upon the number of solute particles, not on the nature of the solute. Is known as the colligative property. Clear? Next, What is the osmotic pressure? What is the osmotic pressure? Osmotic pressure ಅಂದ್ರೆ ಏನು? ಈಗ movement of the solvent particles through the semi-permeable membrane from the lower concentration to the higher concentration alva, lower concentration to the or solvent to the solution. Clear? Now what is the meaning of the osmotic pressure andre? The minimum pressure required, the minimum pressure that stops the movement of the solvent particles. Now osmotic pressure. Osmotic pressure. What is the meaning of the osmotic pressure? No. Osmotic pressure andre ಏನು? The minimum pressure which stops the movement of solvent particles through SMP, semi permeable membrane, is known as the osmotic pressure. Next, isotonic solution. Now ಒಂದೇ ಒಂದು ನೆನಪಿಟ್ಕೋಬೇಕು ನೋಡ, isotonic solution ಅಂದ್ರೆ isotonic solution. ಈಗ ಐಸೋ, ಹೈಪರ್ ಅಂಡ್ ದ ಐಪೋ. ಐಸೋ ಅಂತ ಕೊಟ್ಟಿದ್ದೀರಂದ್ರೆ ನಾವು isotonic solution, it has same osmotic pressure. It is having same concentration, or else you can write like this. It has same concentration of, it is having same concentration of solvent and the solution. It is having the same concentration of the solvent and the solution. Solution and the solvent both are having the same concentration, is known as the isotonic solution. Clear? Now next, now what is the effect on vapor pressure and the boiling point of the solvent when the non-volatile solute is added or dissolved in it? ಈಗ ಇಲ್ಲಿ ನೋಡಿ, this is a pure solvent ಅಂದ್ರೆ ಇದರಲ್ಲಿ ಏನು ಇಲ್ಲ. ಓಕೆ, ಲೆಟ್ ಅಸ್ಯೂಮ್ ದಿಸ್ ಇಸ್ ಅ ಪ್ಯೂರ್ ಸಾಲ್ವೆಂಟ್. ಈಗ ಬಿಸಿ ಮಾಡಿದಾಗ ಏನಾಗುತ್ತೆ? there is no other component alva, pure solvent. Very fastly it will be converted into vapors. Clear? Now iga next, if you have added some non volatile solute, idralli first year the vapors will be there alva. Now these are of the pure solvents. Now after adding the non volatile solute, non-volatile solute will be occupied on the surface alva. Now ಏನಾಗುತ್ತೆ? Now due to the occupied of this non-volatile solutes, now vapor pressure will be decreases. Clear? Now andre here what is the effect of vapor pressure on the solvent when you have added the non-volatile solute alva? Now first one, vapor pressure of pure solvent, ಏನಾಗುತ್ತೆ? vapor pressure of the pure solvent when you add the non volatile solute ಏನಾಗುತ್ತೆ? increase ಆಗುತ್ತಾ ಕಡಿಮೆ ಆಗುತ್ತಾ? ಈಗ non volatile solute will be occupied on the surface ಅಲ್ವಾ? ಅದಕ್ಕೋಸ್ಕರನೇ then vapor pressure will be decreased. Vapor pressure of the pure solvent on adding of non-volatile solute, vapor pressure decreases. ಕ್ಲಿಯರ್ ಆಯ್ತಲ್ವಾ? ನೌ ಹಿಯರ್ ನೆಕ್ಸ್ಟ್ ಬಾಯ್ಲಿಂಗ್ ಪಾಯಿಂಟ್ ಏನೇ ತಗೊಳ್ಳಿ. ಬಾಯ್ಲಿಂಗ್ ಪಾಯಿಂಟ್ ಈಗ ನೌ ದಿಸ್ ಈಸ್ ದ ಪ್ಯೂರ್ ಸಾಲ್ವೆಂಟ್. ಪ್ಯೂರ್ ಸಾಲ್ವೆಂಟ್. Now here the non-volatile solute has been occupied alva. Non-volatile solute has been occupied. Now before the pure solvent, now ಈಗ ಬಿಸಿ ಮಾಡಿದಾಗ let assume at 50 degree now it is converting into vapors. At 50 degree it is converting into vapors. When ಎಲ್ಲಾನು pure ಇದಾಗ, when the solvent is pured, now after adding the non-volatile solute, now this will occupy on the layer of the liquid alva. Now ಈಗ ಬಿಸಿ ಮಾಡಿದಾಗ ಏನಾಗುತ್ತೆ? what it will happen? Now boiling point will be increased. ಯಾಕಂದ್ರೆ this non-volatile solute will not allow the liquid to boil very fastly. ಅದಕ್ಕೋಸ್ಕರನೇ it requires 100 degree. When the non-volatile solute is added, now boiling point will be increased. Clear? Now boiling point of pure solvent, on adding of non-volatile solute, boiling point increases. Clear ಆಯ್ತಾ ಅಲ್ವಾ? ನಾವು ವ್ಯಾಪರ್ ಪ್ರೆಷರ್ ಏನಾಗುತ್ತೆ? ಕಡಿಮೆ ಆಗುತ್ತೆ. ಬಾಯ್ಲಿಂಗ್ ಪಾಯಿಂಟ್ ಏನಾಗುತ್ತೆ? ಜಾಸ್ತಿ ಆಗುತ್ತೆ. ಕ್ಲಿಯರ್? ಡನ್. ನೆಕ್ಸ್ಟ್ ಕ್ವಶನ್. ಈಗ show that half-life period of the first order reaction is independent of the initial concentration of the reacting species anta. Now first order reaction. Now what is the formula of the first order reaction? First order reaction formula ಏನು? K is equal to 2.303 by T log initial concentration by concentration at a time T alva, at a concentration at a time T. Now but he is asking show that the T off of the first order reaction is independent of the initial concentration. Okay, now initially concentration at a time T is equal to 0. Initially the concentration is A0. After the time 50%, at a time 50, now ಈಗ ಎಷ್ಟು ತಗೊಂಡಿದಿರೋ concentration of A will become half alva. ಅಂದ್ರೆ we have started with the 100. After the 50, now it will become 50 andre after the 50 minutes, now initial concentration will become half alva. Andre it will become 50. That 50 I can write in this manner alva, 100 by 2. In the same way at T50 percent, I am writing A0 by 2. Initial concentration kadme aitalva by 2. Now this T50, this is concentration at a time T. Initial concentration at the time T at 50%. Now it has initial concentration has become half alva. Now he is asking T50. Now T50% is equal to 2.303 by K log initial concentration by concentration at time T. Initial concentration by 2 alva. Initial concentration will get cancelled. 2 will go to the numerator side. ಏನಾಗುತ್ತೆ? 2.303 by K log 2. It will be the 2.303 by log K 0.303. Then it will give the 0.697 by K alva. Now T of formula. This is the T of formula. Clear? Now Here the T of is independent of the initial concentration. Independent of the initial concentration. ಯಾಕಂದ್ರೆ at T 50% initial concentration off ಆಗುತ್ತಲ್ವಾ, it will become off. Clear? Next. A first order reaction is found to have rate constant K. Find its T 50%. ಈಗ a first order reaction is found to have a rate constant K. Rate constant K is to 5.5 into 10 to the power minus 14 second inverse. Find its T 50%. Find its T 50%. Find its T 50% ಅಂತ ಕೇಳ್ತಾ ಇದ್ರಲ್ವಾ. Now ಈಗ how to find out the T 50%? How to find out the T 50% ಈಗ ನೋಡಿದೀವಲ್ವಾ. T 50% ಫಾರ್ಮುಲಾ ಏನು? T 50% is equal to first order reaction of the T 50%, or else ಇಲ್ಲಿ ನೋಡಿ. Now here show that the half life period of the first order reaction is independent of the initial concentration. We have derived this one. Now ಈಗ which one? ಇದನ್ನ ಕ್ವಶನ್ ಗೆ ಸೇಮ್ ಒನ್. what I am asking now, show that the half life period of dash order of the reaction is ಡಿಪೆಂಡೆಂಟ್ ಆನ್ ದ ಇನಿಷಿಯಲ್ ಕಾನ್ಸಂಟ್ರೇಷನ್. ಈಗ ಕಾಮೆಂಟ್ ಬಾಕ್ಸ್ ಅಲ್ಲಿ ಕಾಮೆಂಟ್ ಮಾಡಿ. ಕ್ಲಿಯರ್ ಆಯ್ತಲ್ವಾ? ಈಗ ನಾನು ನೋಡ್ತೀನಿ ಹೌ ಮೆನಿ ಆಫ್ ಯು ಆರ್ ಪರ್ಫೆಕ್ಟ್ ವಿತ್ ದ ಕೆಮಿಕಲ್ ಕೈನೆಟಿಕ್ಸ್ ಅಂತ ಈಗ ನೋಡ್ತೀನಿ. ಈಗ ಈ ಕ್ವಶನ್ ನ ಇಫ್ ಇನ್ನೊಂದ್ಸರಿ ಏನ್ ಮಾಡುತ್ತಂದ್ರೆ, ಒಂದೊಂದ್ಸರಿ ಏನಾಗುತ್ತಂದ್ರೆ ಕ್ವಶನ್ ದೆ ಮೇ ಗಿವ್ ಇನ್ ದ ಡಿಫರೆಂಟ್ ಮ್ಯಾನರ್, ದೇರ್ ಯು ಮೇ ಗೆಟ್ ಎ ಕನ್ಫ್ಯೂಷನ್. ಕ್ಲಿಯರ್ ಆಯ್ತಲ್ವಾ? ಈಗ ನಾನೇನ್ ಕೇಳ್ತಾ ಇದ್ದೀನಿ ಕ್ವಶನ್ ಅಲ್ಲಿ, ಸಿ show that the half life period of dash order reaction is dependent on the initial concentration. Dependent on the initial concentration of the reacting species. Which order ಅಂತ ಈಗ ಕಾಮೆಂಟ್ ಬಾಕ್ಸ್ ಅಲ್ಲಿ ಈಗ ಕಾಮೆಂಟ್ ಮಾಡಿ ನಾನು ನೋಡ್ತೀನಿ. ಕ್ಲಿಯರ್ ಆಯ್ತಲ್ವಾ? ಆರ್ ಎಲ್ಸ್ ಇಲ್ಲ. ಈಗ ನೀವು ಕಾಮೆಂಟ್ ಬಾಕ್ಸ್ ಅಲ್ಲಿ ಈಗ ಏನಾದರೂ ಡಿಫರೆನ್ಸ್ ಆನ್ಸರ್ ಕೊಟ್ಟಿದ್ದೀರ ಅಂದ್ರೆ ನಾವು ಎಲ್ಲಾನು ಏನಾಗುತ್ತೆ, ನಿಮ್ಮ ಬೋರ್ಡ್ ಎಲ್ಲಾನು ಮೋಯ್ ಆಗುತ್ತೆ. ಎಲ್ಲ ಮೋಯೆ ನಿಮ್ಮ ಬೋರ್ಡ್ಸ್ ಮೋಯೆ ಮತ್ತೆ ಸೆಕೆಂಡ್ ಇಯರ್ ಎಂಟೈರ್ ಸೆಕೆಂಡ್ ಇಯರ್ PUC ಬೋರ್ಡ್ ಮೋಯ್ ಆಗುತ್ತೆ, KCTನೂ ಮೋಯ್ ಆಗುತ್ತೆ. ಅದಕ್ಕೋಸ್ಕರನೇ ಅಂಡರ್ಸ್ಟ್ಯಾಂಡ್ ದ ಕಾನ್ಸೆಪ್ಟ್. ಏನ್ ಮಾಡಂದ್ರೆ ಡೋಂಟ್ ಮಗ್ ಅಪ್ ದ ಕಾನ್ಸೆಪ್ಟ್. ಅದಕ್ಕೋಸ್ಕರನೇ ಡೋಂಟ್ ರೀಡ್ ದ ಕಾನ್ಸೆಪ್ಟ್. ಈಗ ಸರ್ ನನ್ನೊಂದು 2 ಮಾರ್ಕ್ಸ್ ಕ್ವಶನ್ಗೆ ಫಸ್ಟ್ ಆರ್ಡರ್ ರಿಯಾಕ್ಷನ್ ಇಸ್ ಇಂಡಿಪೆಂಡೆಂಟ್ ಆಫ್ ದ ಇನಿಷಿಯಲ್ ಕಾನ್ಸಂಟ್ರೇಷನ್, 0 ಆರ್ಡರ್ ರಿಯಾಕ್ಷನ್ ಇಸ್ ಡಿಪೆಂಡೆಂಟ್ ಆನ್ ದ ಇನಿಷಿಯಲ್ ಕಾನ್ಸಂಟ್ರೇಷನ್ ಅಂತ. ಇಫ್ ಯು ಹ್ಯಾವ್ ರೀಡ್ ಲೈಕ್ ದಟ್, ಏನಾಗುತ್ತೆ ಅಂದ್ರೆ ವೆನ್ ಯು ಹ್ಯಾವ್ ಸ್ಟಡೀಡ್, ಈಗ ಸರ್ ನಾನು ಬೆಳಿಗ್ಗೆಯಿಂದ ನಾನು ರಾತ್ರಿ ತನಕ ನಾನು ಓದ್ತಾನೆ ಇದ್ದೀನಿ ಸರ್, ಐ ವಾಸ್ ರೀಡಿಂಗ್ ವೆರಿ ಹಾರ್ಡ್ಲಿ ಸರ್. ಹೌ ಮಚ್ ಟೈಮ್ ಯು ಆರ್ ರೀಡಿಂಗ್, ದಟ್ ಈಸ್ ನಾಟ್ ಇಂಪಾರ್ಟೆಂಟ್. ಹೌ ಮಚ್ ಕಾನ್ಸೆಪ್ಟ್ ಯು ಆರ್ ಅಂಡರ್ಸ್ಟ್ಯಾಂಡಿಂಗ್ ಈಸ್ ದ ಮೇನ್ ಥಿಂಗ್ ಓವರ್ ಹಿಯರ್. ಆಯ್ತಲ್ವಾ? ಎಷ್ಟು ಕಾನ್ಸೆಪ್ಟ್, ಹೌ ಮಚ್ ಕಾನ್ಸೆಪ್ಟ್ ಯು ಆರ್ ಅಂಡರ್ಸ್ಟ್ಯಾಂಡಿಂಗ್, ಹೌ ಮಚ್ ಕಾನ್ಸೆಪ್ಟ್ ಯು ಆರ್ ಕೀಪಿಂಗ್ ಇನ್ ಯುವರ್ ಮೈಂಡ್, ದಟ್ ಈಸ್ ಇಂಪಾರ್ಟೆಂಟ್. ದೇ ಮೇ ಚೇಂಜ್ ದ ಕ್ವಶನ್ ಆಲ್ಸೋ, ಯು ಆರ್ ರೆಡಿ ಟು ಪ್ರಿಡಿಕ್ಟ್ ದ ಕ್ವಶನ್ ಆ್ಯಂಡ್ ಯು ಹ್ಯಾವ್ ಟು ಗಿವ್ ದ ಆನ್ಸರ್. ಆಯ್ತಲ್ವಾ? ಈಗ ನಾನು ಒಂದು ಕ್ವಶನ್ ಕೇಳಿದ್ದೀನಲ್ವಾ, ದಟ್ ಕ್ವಶನ್ನ ಈಗ ನೀವು ಕಾಮೆಂಟ್ ಬಾಕ್ಸಲ್ಲಿ ಈಗ ಕಾಮೆಂಟ್ ಮಾಡಿ ನಾನು ಕೊಡ್ತೀನಿ. ಕ್ಲಿಯರ್? ನೆಕ್ಸ್ಟ್, a first order reaction is found to have a rate constant K. Find its T 50%. T 50% just now we have solved alla. What is that? 0.693 by K. Now rate constant value they have given alva. T 50% is equal to 0.693 by K value is to 5.5 into 10 to the power minus 14 second inverse. Clear? Now solve this question and T 50% of the first order reaction. Sir, ಈಗ T 50% of the first order reaction ಈಗ ಆನ್ಸರ್ ನ ಕಾಮೆಂಟ್ ಬಾಕ್ಸ್ ಅಲ್ಲಿ ಕಾಮೆಂಟ್ ಮಾಡಿ ವಿತ್ ದ ಪ್ರಾಪರ್ ಯೂನಿಟ್. ಇದರಲ್ಲಿ ದೇ ಹ್ಯಾವ್ ನಾಟ್ ಆಸ್ಕ್ಡ್ ದ ಯೂನಿಟ್, ವಿತ್ ಪ್ರಾಪರ್ ಯೂನಿಟ್, ಆನ್ಸರ್ ವಿತ್ ಯೂನಿಟ್ ಇದರಲ್ಲಿ ಯೂನಿಟ್. ಕ್ಲಿಯರ್? ವಾಟ್ ಇಸ್ ದ ಯೂನಿಟ್ ಆಲ್ಸೋ ಯು ಹ್ಯಾವ್ ಟು ಆನ್ಸರ್. ಕ್ಲಿಯರ್? ನೆಕ್ಸ್ಟ್ now what is the pseudo first order reaction? Give one example. ಈಗ pseudo first order reaction ಏನಂದ್ರೆ it looks like a bimolecular reaction. ಅಂದ್ರೆ it looks like a second order reaction, but reality it is not a second order reaction, it is purely the first order reaction. It is purely the first order reaction. ಯಾಕಂದ್ರೆ ಈಗ ನೋಡಿ, if you have taken the CH3C double bond O, CH3COO C2H5, now iga this is excess andre let's take this is a 1000 grams alli 1000 grams of the water, only the 1 gram of this reactant species is reacting. Andre this 1 gram has been converted into products. The remaining 9999 grams of H2O is unreacted alva, is unreacted. Means the rate will be depend upon only this. Rate will be depend upon only on this species, not on the reactant which is left, or reactant which is in the excess. Reactant which is in the excess. Pseudo first order reaction. You have to be very very careful. Bimolecular reaction that is made to behave like a first order reaction. ಯಾಕಂದ್ರೆ excess ಅಂದ್ರೆ it will not converting into the products alva. Remaining 1000 grams ಅಲ್ಲಿ 1 gram of the this A and we have taken the H2O ಅಂದ್ರೆ now remaining 99,900 has been left as an reactant only alva. ಅದಕ್ಕೋಸ್ಕರನೇ the rate will be depend upon only this. ಅದಕ್ಕೋಸ್ಕರನೇ this is a first order reaction. It will not depend upon the excess molecule. Then next, explain the effect of catalyst on the activation energy of a reaction with the graph. Now idralli this we have taken the potential energy, here we have taken the potential energy, now here the reaction process. Clear? Now iga here this is the activation energy. This is the activation energy. This is the activation energy of the normal reaction. This is the activation energy of the normal reaction. Iga this green color activation energy, what is the delta H value? What is the delta H value for this one? No, what is the delta H value for the green one? Now delta H is equal to activation energy of the forward reaction minus activation energy of the backward reaction. Activation energy of the forward reaction. Higa reactant ge this much energy it is having. This reactant to convert into products, it should cross its threshold energy. This is the threshold energy. Clear? Now this reactant to form a products, ಏನು ಮಾಡಬೇಕು? It should cross the threshold energy. When it has crossed the threshold energy, this much threshold energy, then it will convert into the products. Clear? Now ಈಗ ಇಲ್ಲಿ ನೋಡಿ, this from the reacting species to this threshold energy, this much energy we call it as a activation energy. From the reactants, this is the reactants activation energy of forward. Clear? Now ಈಗ ನೀವು products again to want to make into the reactant, this products again if you want to make into the reactant, now this is the products activation energy. Or EA backward reaction or products activation energy. Now ಈಗ delta H. Now this delta H, ಈಗ ಈ reaction ಗೆ delta H is positive or negative. It is exothermic reaction or endothermic reaction. Now by this we can calculate. ಇದನ್ನ ನೋಡಿ, delta H is equal to activation energy of the forward reaction. Activation energy of the forward reaction is less. Activation energy of the backward reaction is high alva. Activation energy of the forward reaction is less. activation energy of the backward reaction or activation energy of the reactants is less, activation energy of the products is high alva. Andre this is low minus high, low minus high. Andre this is 5 minus, let us assume 7. Andre delta H is negative, delta H is negative. Andre process is exothermic, process is the exothermic. But the question is, now the question ಕೇಳಿದ್ರಲ್ವಾ, whatever the question they have asked, that is not depend upon this. The question they asked, what is the effect of the catalyst on the activation energy of the reacting species? ಈಗ ಇಲ್ಲಿ ನೋಡಿ, here there is one reactant. ಈಗ ಈ reactant ಗೆ product convert ಮಾಡೋಕೆ ಎಷ್ಟು threshold energy, this much energy it should cross, up to its threshold energy it should reach. ಈಗ after that it should convert into product ಅಲ್ವಾ. ಈಗ catalyst ಏನು ಮಾಡುತ್ತಂದ್ರೆ it will decrease the threshold energy, it will decrease the threshold energy. ಇಲ್ಲಿ ನೋಡಿ ಫಸ್ಟ್ ನ it should cross this much energy alva, then it will convert into product. After if you add the catalyst ಏನಾಗುತ್ತೆ, threshold energy ಕಡಿಮೆ ಆಗುತ್ತೆ. Now you see threshold energy has been came. Now only this much energy if it is crossed, it will convert into product. ಅಂದ್ರೆ catalyst, what the effect of the catalyst? Catalyst will decreases the threshold energy. Clear? Catalyst will decreases the threshold energy ಅಷ್ಟೇ. Okay? Catalyst will decreases the threshold energy. Next, now define the collision frequency and the temperature coefficient. Now collision frequency ಮತ್ತು temperature coefficient ಏನಂದ್ರೆ, collision frequency ಏನಂದ್ರೆ the average rate at which two reactants collide in the given system. Two reactants collide in the given system is known as the collision frequency. ಈಗ 2 marks ಗೆ ಕೇಳಿದಿರಲ್ವಾ, ಇಷ್ಟು ಬರೆದ್ರೆ ಸಾಕು. ನಾವು ಟೆಂಪರೇಚರ್ ಕೋಫಿಷಿಯಂಟ್ ಅಂದ್ರೆ ಏನಂದ್ರೆ, for every 10 degree raise in temperature, rate of the reaction is doubled. ಯಾಕಂದ್ರೆ rate of the reaction is directly proportional to the temperature. ಇಲ್ಲಿ ನೋಡಿ, A is converting into B. ನಾವು ಈಗ rate law ಹೆಂಗ್ ಬರಬಹುದು for this one? Rate is equal to K, rate constant K at the concentration of the A alva. Now this rate constant will be depend upon only temperature. You have to be very careful. This will be depend upon only the temperature. Only on the temperature. How much temperature it is? If the temperature is doubled. Now ಇಲ್ಲಿ ನೋಡಿ, ಈಗ initial temperature by the final temperature. Now let's assume the initial temperature is K1. After initially its temperature is U1. Initially its temperature is K1, let us assume. Now after you giving the 10 degrees extra temperature for this rate constant, now ಏನಾಗುತ್ತೆ, now the rate will be doubled. 2K1, it will become 2K1 by giving the 10 degrees extra temperature, so that the rate will become double. Clear? ಅದಕ್ಕೋಸ್ಕರ ಯಾಕೆ rate constant is directly proportional to the temperature only. Then next, at which electrode will oxidation occur in the galvanic cell and the electrolytic cell? Now this is very very important. ಇನ್ನೊಂದು ತರನು they can ask the question. Now ಈಗ at which electrode oxidation occur in a galvanic cell and electrolytic cell ಅಂತ ಕೇಳ್ತಾ ಇದ್ರಲ್ವಾ. Now ಇದನ್ನ ಕ್ವಶನ್ ನ ಫಸ್ಟ್ I will explain. ಈಗ ನೀವೇನ್ ಮಾಡಂದ್ರೆ now I will give another question in this different manner that you comment over in the comment box for the electrochemistry chapter. ಫಸ್ಟ್ ನಾನು ಈಗ ಏನು ಮಾಡ್ತೀನಿ ಅಂದರೆ, ಫಸ್ಟ್ ಈಗ ನಾನು ಇದು ಎಕ್ಸ್ಪ್ಲೇನ್ ಮಾಡ್ತೀನಿ. ಈಗ ಈ ಕ್ವಶನ್ ಎಕ್ಸ್ಪ್ಲೇನ್ ಮಾಡ್ತೀನಿ, ಆಮೇಲೆ ನಾನು ಯಾವ್ದು ಕ್ವಶನ್ ಅಂತ ನೀವು ಕಾಮೆಂಟ್ ಬಾಕ್ಸಲ್ಲಿ ಕಾಮೆಂಟ್ ಮಾಡಿದ ಯಾವ್ದು ಕ್ವಶನ್ ನಾನು ಬರ್ತೀನಿ. ಓಕೆ ಫೈನ್. ಇಲ್ಲಿ ನೋಡಿ, at which electrode oxidation occur. Oxidation ಅಂದ್ರೆ ಏನು? Loss of electrons ಅಲ್ವಾ? Loss of electron. Let assume zinc ತಗೊಳ್ಳಿ. Zinc by losing its two electrons, now this is a oxidation ಅಲ್ವಾ? Galvanic cell or electrochemical cell. Galvanic cell or the electrochemical cell. No, this is a galvanic cell or electrochemical cell ಅಲ್ವಾ? Here the two electrodes, now connected with the external battery. Okay, now this is a salt bridge. Okay, now this is a galvanic cell. Electrolytic cell ಅಂದ್ರೆ ಏನು? Now the two electrodes will present in the same vessel. Alva. Now this is a galvanic cell. Now this is a electrolytic cell or electrochemical cell. This is okay. Now my question is oxidation alva andre loss of electrons. Oxidation, let assume this is anode. Now this is cathode. Now idralli let assume this is anode. Now this is cathode. Now whatever it may be the cell, either it may be the electrochemical cell or else a electrolytic cell. Electrochemical cell or the electrolytic cell. Now in the both the cases oxidation occur at anode only in the both the cells. Either galvanic cell or the electrolytic cell. In the both the cells, oxidation will occur at the anode only. Clear aithalva? Oxidation will occur at the anode only in the both the cells. Oxidation occur at the anode only. Clear? Now my question higa, as per this question, this is the data. Oxidation occur at the anode only for the both the cells. My question, nan question ಏನಂದ್ರೆ, in galvanic cell and electrolytic cell, what is the charge of anode and cathode? Now in the galvanic cell ಮತ್ತೆ electrolytic cell ಅಲ್ಲಿ, electrochemical cell ಅಲ್ಲಿ ಮತ್ತೆ electrolytic cell ಅಲ್ಲಿ, now what is the charge of anode, what is the charge of cathode? What is the charge of anode, what is the charge of the cathode? Clear? What is the charge of the cathode, what is the charge of anode? What is the charge of anode, what is the charge of the cathode ಅಂತ ಕಾಮೆಂಟ್ ಬಾಕ್ಸ್ ಅಲ್ಲಿ, ಈಗ ಈ ಕ್ವೆಶ್ಚನ್ಗೆ ಕಾಮೆಂಟ್ ಬಾಕ್ಸ್ ಅಲ್ಲಿ ನೀವು ಕಾಮೆಂಟ್ ಮಾಡಿ ನಾನು ನೋಡ್ತೀನಿ. ಕ್ಲಿಯರ್? ನಾವು ಇನ್ನೊಂದು ಸಾರಿ ದೇ ಮೇ ಆಸ್ಕ್ ಇನ್ ದ ಡಿಫರೆಂಟ್ ಮ್ಯಾನರ್ ಆಲ್ಸೋ. ಈಗ ಈ ಕ್ವೆಶ್ಚನ್ ಈಗ ಈ ತರ ಕೊಟ್ಟಿದ್ರಲ್ವಾ, ಸಮ್ ಟೈಮ್ಸ್ ದೇ ಮೇ ಆಸ್ಕ್ ದ ಕ್ವೆಶ್ಚನ್ ಇನ್ ದಿಸ್ ಮ್ಯಾನರ್ ಆಲ್ಸೋ. ಡನ್? ನೆಕ್ಸ್ಟ್ ಸ್ಟೇಟ್ ದ ಫ್ಯಾರಡೇಸ್ ಸೆಕೆಂಡ್ಸ್ ಲಾ ಮತ್ತೆ ಕೋಲರಾಸ್ ಲಾ. ನಾವು ಇಲ್ಲಿ ನೋಡಿ, ಫ್ಯಾರಡೇಸ್ ಸೆಕೆಂಡ್ ಲಾ ಏನಂದ್ರೆ, ದಿ ಸೇಮ್ ಅಮೌಂಟ್ ಆಫ್ ದ ಎಲೆಕ್ಟ್ರಿಸಿಟಿ. ನಾವು ಫ್ಯಾರಡೇಸ್ ಲಾ ಅಲ್ಲಿ ಇಫ್ ಯು ಹ್ಯಾವ್ ಟೇಕನ್ 3 vessels, now the same electricity is passed through the different electrolytes. Idralli, if you have taken a one electrolyte, if you have taken a one electrolyte, if you have taken a one electrolyte, now the mass of the ion deposited at the electrodes are directly proportional to their gram equivalents. In these three electrodes, the mass of the ions deposited is directly proportional to their chemical equivalence, is known as the Faraday's second law. Faraday's second law. Next, what is the Cole-Rash law? What is the meaning of the Cole-Rash law? ಈಗ Cole-Rash law ಏನಂದ್ರೆ Cole-Rash law ಏನಿಲ್ಲ, ನಾವು ಈಗ ಲಿಮಿಟಿಂಗ್ ಮೋಲಾರ್, ಈಗ ಮೋಲಾರ್ ಕಂಡಕ್ಟೆನ್ಸ್ ಆಫ್ ದ ಸ್ಟ್ರಾಂಗ್ ಎಲೆಕ್ಟ್ರೋಲೈಟ್ ತಗೊಂಡಿದೀವಿ ಅಂದ್ರೆ ಯು ಕ್ಯಾನ್ ಕ್ಯಾಲ್ಕುಲೇಟ್. ಯಾಕಂದ್ರೆ ಈಗ ಲಿಮಿಟಿಂಗ್ ಮೋಲಾರ್ ಕಂಡಕ್ಟೆನ್ಸ್ ಆರ್ ಮೋಲಾರ್ ಕಂಡಕ್ಟೆನ್ಸ್ ಆಫ್ ದ ಸ್ಟ್ರಾಂಗ್ ಎಲೆಕ್ಟ್ರೋಲೈಟ್ ಯು ಕ್ಯಾನ್ ಬಿ ಕ್ಯಾಲ್ಕುಲೇಟೆಡ್. ಯಾಕಂದ್ರೆ ಸ್ಟ್ರಾಂಗ್ ಎಲೆಕ್ಟ್ರೋಲೈಟ್ ಆಫ್ಟರ್ ಇಫ್ ಯು ಡ್ರಾಪಿಂಗ್ ಇನ್ ದ ವಾಟರ್ ಏನಾಗುತ್ತೆ, ಇಟ್ ವಿಲ್ ಬಿ ಕಂಪ್ಲೀಟ್ಲಿ ಕನ್ವರ್ಟೆಡ್ ಇಂಟು ಅಯಾನ್ಸ್ ಅಲ್ವಾ, ಅಂದ್ರೆ 100% ಡಿಸೋಸಿಯೇಷನ್ ಆಗುತ್ತೆ, 100% ಡಿಸೋಸಿಯೇಷನ್ ಆಗುತ್ತೆ ಫಾರ್ ದ ಸ್ಟ್ರಾಂಗ್ ಎಲೆಕ್ಟ್ರೋಲೈಟ್. ಬಟ್ ಈಗ ವೀಕ್ ಎಲೆಕ್ಟ್ರೋಲೈಟ್ ತಗೊಂಡಿದ್ವಿ ಅಂದ್ರೆ ಏನಾಗುತ್ತೆ, ವೀಕ್ ಎಲೆಕ್ಟ್ರೋಲೈಟ್ ವಿಲ್ ನಾಟ್ ಬಿ ಕನ್ವರ್ಟೆಡ್ ಇಂಟು 100% ಅಯಾನ್ಸ್ ಅಲ್ವಾ. ಅದಕ್ಕೋಸ್ಕರನೇ to calculate the molar conductance of the weak electrolyte, ನಾವೇನ್ ಮಾಡ್ಬೇಕಂದ್ರೆ we have to dilute, keep on diluting. ಏನಾಗುತ್ತೆ, keep on the dilution, ions, all the ions. See, in the 1 ml, let us assume 100 ml, now 0.05 as acetic acid has been dissociated. If I increase it to the 1 liter, its dissociation has been came to the 1. If I increase the dilution, now if I increase it to the 10 liters, its dissociation has came to the 10. That's the reason if I keep on diluting, ಏನಾಗುತ್ತೆ, the acidic or weak electrolytes will also completely ionize alva. But adu how much molar conductance, it is giving, that it was calculated indirectly by the law called as a Cole-Rash law. Clear? Now the equivalent conductivity of an electrolyte at infinity dilution is equal to the sum of conductance of anions and the cations. Sum of the conductance of the anions and the cations. Okay, sum of the conductance of the cations and the anion. Molar conductance of the weak electrolyte at the infinity dilution. Sum of the conductance of the anions and the cations. Clear? Next. Write the cathodic and the anodic cell reaction of the hydrogen and the oxygen fuel cell. This is a fuel example for the fuel cell alva. Now in the oxygen and the hydrogen fuel cell alli at the anode ಏನಾಗುತ್ತೆ, anode oxidation. Now cathode alli whatever it may be the cell, at the cathode ಏನಾಗುತ್ತೆ, reduction. At the anode oxidation, cathode reduction alva, ಇಲ್ಲಿ ನೋಡಿ, H2 gas, its oxidation number is 0, because ಯಾಕಂದ್ರೆ H2 it is present in the gas alva. H2 it is present in the gas, andre it is present in its standard state. H2 is more stable in the hydrogen is more stable in the gas alva, ಅದಕ್ಕೋಸ್ಕರನೇ its standard state ಅಲ್ಲಿ ಇದೆಯಲ್ವಾ, ಅದಕ್ಕೋಸ್ಕರನೇ its oxidation number is 0. Done. Now when it comes here, its oxidation number ಎಷ್ಟು, ಇದರಲ್ಲಿ oxidation number ಎಷ್ಟು. Now ಈಗ 2x minus 2 is equal to 0 alva. If you take this one, this will become, andre this has been loss of electrons alva, loss of electrons. It has been lost the electrons, andre this is oxidation. Oxidation has been occurred alva. Now next reduction andre gain of electrons alva. O2 is converting into the hydroxy. There it is gaining the electron. There it is gaining the electron. Clear? Now the net reaction will be the H2 gas plus O2 gas gives rise to 2HO liquid. 2HO liquid. Now this is the cathodic and the anodic reactions of the hydrogen and the oxygen fuel cell. Oxygen fuel cell. Clear? Next, draw the neat labeled diagram of the standard hydrogen electrode. Write its off cell reaction and mention its E0 value. Iga standard hydrogen electrode. Now this is useful to calculate the E cell. Now here this is the off cell of the standard hydrogen electrode or the normal electrode. But this standard hydrogen electrode, this is the diagram of the standard hydrogen electrode. Clear? Now, you guys, standard hydrogen electrode by passing the H2 gas, here they have quoted the platinum. And this wire has been connected to the another off cell. Clear? Now, here we have taken the 1 molar of H plus concentration. 1 molar of H plus concentration. Either we can take the HCl or H2SO4, any acid. Clear? The any acid which will give the H plus. Clear? Or strong acid. 1 molar of the H plus ion concentration we have taken, alva. Now here from here we are passing the H2 gas. Here the down we are coated with the platinum coated. Clear? Platinum coated. Now this is the diagram of the standard hydrogen electrode. SHE is the basically off cell. This is the off cell reaction, only the off cell. But the standard hydrogen electrode will act as the anode, will act as the cathode. Next, what you are asking? Now write the off reaction and mention its E0 value. Now this standard hydrogen electrode will act as the both, alva? Both. It will act as the anode, it will be act as the cathode. Now, they are asking write the off cell reaction. When it act as the anode, when it will act as the cathode andre. Iga this is off cell. Now, if you want to calculate, this is the hydrogen, let assume if you want to calculate the off cell or E0 value of the copper, then hydrogen SHE will act as the anode or cathode. The one which is having the higher SRP, will act as the cathode. The one which is having the lower SRP will act as the anode. Clear? Now, when it is acting as the anode, oxidation occur. Yakandre yavadannai cell, whatever it may be the cell. Now, anode oxidation will occur. Cathode reduction will be occur. Clear? Now, SHE will act as both the anode and the cathode alone. Now, when it is acting as the anode, now this is the off cell reaction. H2 gas now oxidized to the H plus by losing its 2 electrons. Next, when it is acting as a cathode, 2H plus 2 electrons gain and it is dissolved and it is reduces to the H2 gas. Clear? Now, if the SHE standard hydrogen electrode SRP is higher than other or which you want to calculate, other than or other element or other metal, it acts as a cathode. Yakandre the one which is having the higher SRP will act as a cathode, the one which is having the lower SRP will act as a anode. Clear? Now its E0 value for the standard hydrogen electrode is 0. Adigoskaram will take it as a reference electrode. Reference electrode value is 0. E0 value for the standard hydrogen electrode is 0. Clear? Next. Define the limiting molar conductivity. Name the state, the law which helps the determining the limiting molar conductivity of the weak electrolyte. Just now iga nanu molar conductivity of a solution at infinity dilution. Infinity dilution andre at infinity dilution strong electrolyte tagondidandre KCl anta tagoli. KCl is a strong electrolyte alva. Now it will be completely ionized to the K plus and the Cl minus. It is strong electrolyte. It will be completely ionized to the K plus ಮತ್ತೆ Cl minus. But ಈಗ weak electrolyte ತಗೊಂಡಿದ್ದೀವಿ ಅಂದ್ರೆ but the weak electrolyte ತಗೊಂಡಿದ್ದೀವಿ ಅಂದ್ರೆ ಏನಾಗುತ್ತೆ weak electrolyte it is not completely ionized ಅಲ್ವಾ, it not completely ionized. ಈಗ ನೋಡಿ here if you take molar conductivity and its concentration clear. Now KCl it is a strong electrolyte. It will be converted into K plus and the Cl minus. It is completely ionized alva, completely ionized. Now here concentration molarity is equal to number of moles by volume in liter alva. Now if the volume increases upon dilution concentration kadme aguttalva, concentration kadme agutte means the concentration it will be and it will touch here and it will be touch here yakandre this is completely ionized. Now in the molar conductance for the strong electrolyte they will give the graph in this manner, but for the weak electrolytes ಏನಾಗುತ್ತೆ ಅಂದ್ರೆ weak electrolyte will not be completely ionized alva, it is not completely ionized. Now when it is not completely ionized now ಏನಾಗುತ್ತೆ ಅಂದ್ರೆ now same thing upon dilution concentration ಕಡಿಮೆ ಆಗುತ್ತಲ್ವಾ. Now here the concentration is high, now concentration will become low, it will become low and it will not touch the y axis. yakandre if it is touching the y axis it represents the 100% dilution. Clear. Now ಈಗ strong electrolyte ಗೆ upon dilution concentration kadme agutalva, up to here it is reached. By extrapolation we can calculate the molar conductance, iga weak electrolyte ge we cannot calculate alva, yakandre it is not touching the y axis. Now indirect manner yavudu, that the help of the Kohlraasch law, with the help of the Kohlraasch law we can calculate the limiting molar conductivity of the weak electrolyte, at infinity dilution. ಏನಾಗುತ್ತೆ at infinity dilution ಅಂದ್ರೆ ಏನನು I said alwa, if you have taken 10 ml, now acetic acid has been dissociated as a 0.05. Now if you have taken a 1 liter, it has been came to the 0.5. Now dissociation of the acetic acid, weak electrolyte. Now if you have taken a 100 ml or if you have taken a 10 liter, now it has came to the 1. Now if you have taken a 1000 liter, it has came to the 10. Now andre upon dilution, keep on dilution, at the infinity all the ions will be converted, all the weak ions or acetic acid ions will be converted into all the ions will be ionized alva, completely ionized alva, at infinity dilution. Clear. ಅದಕ್ಕೋಸ್ಕರನೇ AXBY plus H2O ಈಗ ಕೊಟ್ಟಿದ್ದೀರಂದ್ರೆ now this you know alva, AXBY upon in the presence of H2O, this AXB type if you have dissolved in the H2O it will convert into X a power y plus y b power x minus. Clear. Now this is molar conductance at a limiting molar conductivity of A plus limiting molar conductivity of B, cation and the anion with the help of Kohlraasch law. This is the Kohlraasch law. Okay, next ಈಗ ಒಂದು ಕ್ವಶನ್ ನೋಡೋಣ. ಈಗ ಲಿಮಿಟಿಂಗ್ molar conductivity of an weak electrolyte ಹೆಂಗ್ ಫೈಂಡ್ ಮಾಡಬಹುದು, with the help of the ಯಾವುದು Kohlraasch law ಅಲ್ವಾ, Kohlraasch law. Now ಈಗ ಇದರಲ್ಲಿ ಏನು ಕೊಟ್ಟಿದ್ದಾರೆ ಅಂದ್ರೆ limiting molar conductance of the MgCl2, ಕೊಟ್ಟಿದ್ರಲ್ವಾ. Now the limiting molar conductance of the MgCl ಕೊಟ್ಟಿದ್ರಲ್ವಾ, the limiting molar conductance of the Mg plus 2 and the Cl minus ions are 106 and the 76.3 Siemens centimeter square mole inverse respectively. Now he is asking limiting molar conductance or molar conductance. Now this can be calculated on the basis of now molar conductance of the MgCl2. Now upon infinity dilution, how it will be how it will be converted? Now, molar conductance at infinity dilution of Mg plus 2 plus its stoichiometric coefficient 2 and limiting molar conductance of Cl minus but Mg no iga Ax By how it will be dissociate no x Ay plus y b x minus alva andre Mg Cl2 Mg is 1 andre 1 Mg plus 2 plus 2 Cl minus 1. Clear? Now Mg Cl2 is equal to limiting molar conductance of the Mg plus 2 ಎಷ್ಟು ಕೊಟ್ಟಿದ್ರು 106. Next limiting molar conductance of Cl minus ion ಎಷ್ಟು ಕೊಟ್ಟಿದ್ರು 2 into 76.3 ಅಂದರೆ 106 plus then it will become 6 12 14 15 152.6 then it will become 250.6. This is the answer. Clear? So this is the answer for the limiting molar conductance of the MgCl2. weak electrolyte ಗೆ limiting molar conductance or molar conductance ಹೆಂಗ್ ಫೈಂಡ್ ಮಾಡಬಹುದು with the help of the Kohler Ash law only we can calculate. For the strong electrolyte, by the extrapolation of the graph, with the help of the graph we can calculate. Then next Irali, give the reason for the following. Actinides generally show the variable oxidation state. Now lanthanides are the less reactive than the actinides. Yake? Now Irali, what is asking? Now give the reason for the following. Actinides generally show a variable oxidation state. Yake? Now lanthanide generally shows oxidation of the plus 3. Generally the lanthanide's common oxidation state is plus 3. But actinides it will show the plus 3 to the plus 7 oxidation state. Yakandre first one now actinides generally show variable oxidation. Now actinides generally show variable oxidation state due to small energy gap between now small energy gap between idralli iga which one it is having the small energy gap? Now when at which period actinides will start, at which period lanthanides will start? Now first period, second period, third period, fourth period, fifth period, sixth period, seventh period. Now sixth period lanthanides will start, seventh period actinides will start alva, seventh period actinides will be start. Clear? Now the lanthanides it is having the 4F. Now actinides it is having the 5F alva, 5F. Andre the energy gap between the 5F and the 6D and the 7S. Due to the energy gap between the 5F, 6D and the 7S, 5F, 6D and the 7S. Now actinides it shows variable oxidation state. Because electrons can go to the higher energy level. Okay? Now lanthanides are less reactive than the actinides. Yakandre now lanthanides due to small size they will not participate in chemical reaction. They will not participate in the chemical reaction. They will not participate in the chemical reaction. They will not participate in the chemical reaction. Adugoskarané lanthanides are less reactive than the actinides. Okay. Next, why the 3D series of elements act as a good catalyst? ಯಾಕಂದ್ರೆ ಈಗ 3D series elements ಯಾವುದು? 3D series elements ಯಾವುದು? 3D series elements mostly scandium, titanium, vanadium, chromium, manganese, ferrous, cobalt, nickel, ferrous, cobalt, nickel, copper and the zinc alva. Now mainly not all will act as a good catalyst, but 3D series elements act as a good conductors. ಯಾಕಂದ್ರೆ 3D series elements due to the presence of vacant orbital, ಯಾವುದು? vacant d orbital. Due to the presence of vacant d orbital, it can show the variable valency or variable oxidation state alva. Due to the presence of vacant d orbital, it will act as a good catalyst. It is a A. Next, B, give the reason Ti+4 salts are colorless whereas the Cr+3 salts are the colored. ಯಾಕಂದ್ರೆ Tr+4 salts are the colorless, Cr+3 salts are the colored ಅಂತ ಕೇಳ್ತಾ ಇದ್ರಲ್ವಾ? ಯಾಕಂದ್ರೆ ಇಲ್ಲಿ ನೋಡಿ Ti+4 ಮತ್ತೆ ಇದರಲ್ಲಿ Cr+3. ನಾವು ಟೈಟಾನಿಯಂ ಆಕ್ಸಿಡೇಷನ್ ನಂಬರ್ ಎಷ್ಟು? ಅಟಾಮಿಕ್ ನಂಬರ್ ಎಷ್ಟು? ಇದು 22, ಇದು 23, ಇದು 24 ಅಲ್ವಾ? Now this is 24. Okay, now this is argon 4s2 3d2. Now this is argon 4s2 3d, argon 4s1 3d5. Clear? 4 electrons has been lost. Andre it has become d0. Now idralli 3 electrons has been lost alva, andre it will become d3. Now here the dd transition is absent. Now when there is no dd transition, now d0 ಮತ್ತೆ d10 both are colorless. ಯಾಕಂದ್ರೆ ಡ್ಯೂ ಟು ದ ಆಬ್ಸೆನ್ಸ್ ಆಫ್ ದ dd transition ಇಲ್ಲಲ್ವಾ? ಅದಕ್ಕೋಸ್ಕರನೇ these are the colorless. Now here the due to the presence of unpaired electrons, dd transition will be happen. Now dd transition is present, and colored, and it is colored. dd transition is present and it is colored. Okay, dd transition is absent. Clear? Next, write the equation for the preparation of the potassium permanganate from the MnO2. How we can prepare the potassium permanganate anta kelta idralva? How we can prepare the potassium permanganate anta kelta idru. Now illi nodi, here KMnO4 is synthesized by the pyrolusite. Now pyrolusite is the cheap ingredient. Now here KMnO4 is synthesized by the pyrolusite. Cheap ingredient is the MnO2. MnO2 is the cheap ingredients of the pyrolusite. Iga this pyrolusite is fused with the base. It will be fused with the base in the presence of oxygen. Clear? Enagutte? What it will give? It will give the potassium manganate. If they ask, write the equation for the preparation of the potassium permanganate anta kelidrandre, potassium permanganate is synthesized by the pyrolusite cheap ingredient is the MnO2. Then clear? Next, this MnO2 in the presence of 4KOH plus O2, 4KOH base plus oxygen gives rise to potassium manganate. This potassium manganate, now the potassium permanganate we can prepare in the electrolytic method, or else we can by the reacting with the H2SO4 we can get the potassium permanganate, or else if you react with the Cl2, we can get the potassium permanganate. Clear? Why? Potassium manganate. In the electrolytic method also, we can get the potassium permanganate. But he is asking some reactions alva, equations alva. So this is 1 and this is 2. Clear? Now potassium manganate is reacting with the concentrated or H2SO4. Then we are getting the potassium permanganate. Now this potassium manganate, again if it is reacting with the Cl2 gas, again we are getting the potassium permanganate. Clear? Now this is the main pyrulicide. First it will give the potassium manganate reacting with the H2SO4, give the potassium permanganate. If it is reacting with the Cl2, will get the potassium permanganate. Clear? Now CO2 also will get, Cl2 also will get, O3 also will get. Clear? Now for the 2 marks question, these 2 equations it is enough. Next, give the reason cerium exhibits the +4 oxidation state. Now lanthanide contraction is greater from the elements to the elements than the lanthanide contraction. Now first question is cerium. Now what is the cerium atomic number? This is 58. Cerium atomic number is a 58 alva. Now why the cerium is exhibiting the +4 oxidation state? Now cerium will comes under the lanthanides alva. When the cerium is coming into the lanthanides, but lanthanides mainly it will show the +3 oxidation state. But cerium ಯಾಕೆ +4 oxidation it is showing andre nodi here 58 electronic configuration ಏನು xenon 4f1 5d1 6s2. This is the general electronic configuration of the cerium. Now cerium, this is the atomic number of the xenon is 54. Clear? Now cerium, if it is lost these 4 electrons, it has reached to the noble gas electronic configuration alva. When it has reached to the noble gas electronic configuration, it is stable, right? That's the reason cerium will show the +4 oxidation state. Cerium by loss of 4 electrons, it reaches to the noble gas electronic configuration. Clear? Next, lanthanide contraction is greater from the elements to elements than the actinide contraction is greater than the element to element than the lanthanide contractions alva. Now will nodi. Now lanthanides, this is nucleus. Now lanthanides will start from the 4f, actinides will start from the 5f alva. Clear? Now this is the valency electron. Now 4f mate 5f ali 5f it is a poor shielding. When the 5f it is a poor shielding, the valency electron will not be protected. Andre valency electron will express the nuclear charge. Or nuclear attraction. Valency electron will express the nuclear attraction. Yakandre idaರಲ್ಲಿ 5f it is a poor shielding compared to the 4f. Compared to the 4f, 5f is a poor shielding. Due to the poor shielding, actinide contraction is greater than the lanthanide contraction. Clear? No. Due to the poor shielding of 5f orbitals, due to the poor shielding of the 5f orbital, valency electron exhibit nuclear attraction. Valency electron exhibit the nuclear attraction than the valency electron exhibit the nuclear attraction. Clear? That's the reason actinide contractions are valency due to the poor shielding of the 5f orbital of the actinides. Valency electrons exhibit the nuclear attraction than the 4f orbital. Clear? Then next, describe the preparation of the potassium dichromate from the chromator. Now, by the pyrolusite we have prepared the potassium permanganate. Now, potassium dichromate ಹೆಂಗ್ prepare ಮಾಡಬಹುದು? we can prepare by the chromator ಅಲ್ವಾ. K2Cr2O7 is synthesized by the chromator. K2Cr2O7 is synthesized by the chromator. This chromator, from the chromator only we can prepare the potassium dichromate. Now here these 4 moles of FeCr2O4 in the presence of base, in the presence of oxygen, by heating we will get the Na2Cr4 plus Fe2O3. Now illodi Na2Cr4 goes into the solution. Fe2O3, ferrous oxide, it is not soluble by the H2O. By the filtration method, these two will be separated out. When we are reacting with the base, ಏನಾಗುತ್ತೆ, the two it will be formed ಅಲ್ಲ, Na2Cr4 plus Fe2O3. Now Fe2O3 is not soluble in the water. Now then what we can do? We can separate out with the filtration. Now after the separating, now the filtrate the Na2Cr4. If it is reacting with the dilute H2SO4, we are getting the sodium dichromate. Which is in the orange color. Clear? Now this sodium dichromate, when we are reacting with the KCl, we are getting the potassium dichromate. We are getting the potassium dichromate and the NaCl. Now due to the solubility difference due to the crystals of the crystallization, fractional crystallization, due to the solubility difference, fractional crystallization, we can separate out the potassium dichromate. Now, this you can, if you write, you will get, it will be helpful for your 2 marks question. Okay, next. Now calculate the spin only magnetic moment. Or magnetic moment of the Mn plus 2 ion spin only magnetic moment is asking. Clear? Mn plus 2. Mn. What is the Mn atomic number? 25 alva. Now this is 1s2, 2s2, 2p6, 3s2, 3p6, 4s2, 3d5. Now this is the up to noble gas electronic configuration. This is Ar, argon. Andre 4s2, 3d5. Mn plus 2 andre 2 electrons should be removed alva. The 2 electrons should be removed from the valency electrons. Valency electron in the 2 electrons has been removed. If you remove the 2 electrons from this valency electrons, now this it will become the electronic configuration, it will become the 3d5 alva. Now spin only magnetic moment formula ಏನು? Under root n into n plus 2 calculate the magnetic moment. Sorry, it's not spin only. Calculate the magnetic moment. Now n into Bohr magnetons. Clear? Now d5 ಅಲ್ಲಿ ಎಷ್ಟು unpaired electrons ಇರುತ್ತೆ? n is the unpaired electron ಅಲ್ವಾ? Now n is the unpaired electron. Now unpaired electron n is equal to 5. Andre this is a 5 is equal to 5 plus 2 Bohr magnetons. Andre this is a 35 Bohr magnetons. Now approximately we'll get a 5.89 something we'll get. Okay, next. Now, using the VBT, explain the geometry, hybridization and the magnetic property of the Ni nickel tetracyanide, nickelate 2 ion, nickelate 2 ion. Clear? Now, here nickel. Now, cyanide is a strong field ligand, alwa? Strong field ligand. Now, the oxidation number X plus 4 minus 1 is equal to minus 2. X is equal to minus 2 plus 4. X is equal to plus 2, alwa? Plus 2. Nickel oxidation number is plus 2. Nickel oxidation number plus 2 andre this is argon 4s2 3d8. Now 2 electrons has been lost, andre this is argon 3d8. 1 2 3 4. Now d subshell contain 5 orbitals, alva? 1 2 3 4 5 6 7 8. But due to the presence of this strong field ligand, ಏನಾಗುತ್ತೆ? pairing ಆಗುತ್ತಲ್ವಾ? Now this electron will be paired here. Now what will get? 1 2 3 4 1 2 3 4 5 6 7 8. Now here the S and here this is the P. Clear? Now how many ligands we are having? 4 ligands we are having, alwa? Now one cyanide, one cyanide. Now the hybridization. Now hybridization is equal to DsP2. This is DsP2. Geometry is a square planar. And is asking, and next what is asking? Magnetic property. It is a diamagnetic or paramagnetic. Now is there any unpaired electrons? There is no any unpaired electrons, alwa? Adukoskara this is a diamagnetic. Okay? Now iga nickel tetracyanide nickelate 2 ga kottidire, nickelate 2 ion ga kottidire andre the hybridization is DsP2, geometry square planar, magnetic property diamagnetic. Yakandre there is no any unpaired electrons. Clear? Next. Now using the valency bond theory, VBT, account geometry, hybridization, magnetic nature of this one. Now hexaamine cobalt 8 plus 3. Amine is a neutral ligand, alwa? Now CO hexaamine cobalt 8 plus 3 ion. No, this is plus 3. Now cobalt oxidation number is plus 3. Now this is having argon 3d6. Yakandre 4s2 3d7 is a cobalt electronic configuration. By losing the 3 electrons, it will reach to the 3d6, alwa? It will reach to the 3d6. 1 2 3 4 5 6. Actually this is the electronic configuration of the d6, alwa? d6 electronic configuration is in this manner. But iga ammonia when it is form a ligand with the cobalt. Now NH3 with cobalt and chromium, it will act as a strong field ligand. Idin inpetkobeku. Clear? Now NH3 with the cobalt and with the chromium. NH3 will act as a strong field ligand. It will act as a strong field ligand, alwa? Now strong field ligand andre enagutte? Pairing aguttಲ್ವಾ? Now pairing agutte. Clear? Now CO with the strong field ligand CRO. Now D6 the pairing. 1 2 3 4 5 6. Clear? Now how many ligands are there? 6 ligands we are having alwa. So this is P. Now one ammonia, now another ammonia, now here the another ammonia, now here the another ammonia, here the another ammonia, now here the another ammonia. Clear? Now this is D2sp3, D2sp3. Due to the presence of these vacant orbitals, now ligands are forming the bond alwa. Now the hybridization is D2sp3. Hybridization is D2sp3. D2sp3. Geometry is inner sphere octahedral. Inner sphere octahedral. Next, what is the next they are asking? Magnetic property or magnetic nature. Magnetic nature. Are you seeing any unpaired electron? Unpaired electrons ಏನಿಲ್ಲಲ್ವಾ, ಅದಕ್ಕೋಸ್ಕರನೇ unpaired electrons ಇಲ್ಲಲ್ವಾ. This is diamagnetic. This is a diamagnetic. Okay, this is a diamagnetic. Done? Clear? Next. Next, what is showing? Draw the energy level diagram of the crystal field splitting in octahedral complex of the D6 with the strong field ligand and with the weak field ligand. ಈಗ ಒಂದು ಸ್ಟ್ರಾಂಗ್ ಫೀಲ್ಡ್ ಲಿಗ್ಯಾಂಡ್ ಮತ್ತೆ ಈಗ ವೀಕ್ ಫೀಲ್ಡ್ ಲಿಗ್ಯಾಂಡ್ ಕೊಟ್ಟಿದ್ದಾರೆ ಅಂದ್ರೆ, now what is the crystal field octahedral complex crystal field splitting energy diagram? Is asking energy diagram of the D6. No, D6. No, this is the D6. 1 2 3 4 alwa. Now 1, now D6 with a weak field ligand. Now weak field ligand, D6 with a weak field ligand, D6 with the weak field ligand. 1 2 3 6 or else with a weak field ligand. 1 2 3 4 1 2 3 4 5 6. Now this will be split into, in octahedral complex it will be split into 2 2g and the Eg alwa. This is 2 2g and this is the Eg. Now this is the barrier. Now here to here the energy, now here 2 2g, now this is the Eg. Okay, here to here the energy gap will be the 0.6, here to the here the energy gap will be the minus 0.4. Okay, now fill the electrons. Now fill the electrons. Due to the weak field ligand there is no pairing alwa, there is no pairing. 1 2 3 4 5 6. Now this is the crystal field energy level diagram for the D6 with the weak field ligand. Next, with a strong field ligand. No. D6 with a strong field ligand. D6 with the strong field ligand. D6 with the strong field ligand ಏನಾಗುತ್ತೆ? 1 2 3, this is 2 2g, so this is Eg. Okay, 1 2 3 1 2 3 4 5 ಇದರಲ್ಲಿ 6. ಕ್ಲಿಯರ್? ನೌ ಈಗ 2 2g ಅಲ್ಲಿ ನಾವು ವಿತ್ ದ ಸ್ಟ್ರಾಂಗ್ ಫೀಲ್ಡ್ ಲಿಗ್ಯಾಂಡ್ ಏನಾಗುತ್ತೆ? ಪೇರಿಂಗ್ ಆಗುತ್ತಲ್ವಾ? ಪೇರಿಂಗ್ ಆಗುತ್ತೆ. ನಾವು ವೆನ್ ದ ಪೇರಿಂಗ್ ಆಗುತ್ತೆ ಅಂದ್ರೆ ನಾವು ಯಾಕೆ? ಡ್ಯೂ ಟು ದಿಸ್ ಎನರ್ಜಿ ಗ್ಯಾಪ್, ಇದರಲ್ಲಿ ಎನರ್ಜಿ ಗ್ಯಾಪ್ ಕಡಿಮೆ ಇರುತ್ತೆ, ಅದಕ್ಕೋಸ್ಕರ ವೀಕ್ ಫೀಲ್ಡ್ ಲಿಗ್ಯಾಂಡ್. ನಾವು ಹಿಯರ್ ದ ಎಲೆಕ್ಟ್ರಾನ್ಸ್ ಆರ್ ಪೇರ್ಡ್ ಇನ್ ದ Eg. Now in the with the strong field ligand energy gap will be higher, ಅದಕ್ಕೋಸ್ಕರನೇ the electron first will paired in the 2 2g, then it will reach to the Eg. Clear? No. Then now this is the energy level diagram for the D6 with the weak field ligand, D6 with the strong field ligand, with the strong field ligand. Clear? Next. draw the geometrical isomerism of FeNH3Cn2. now this is the type of the A4B2 type. Now two geometrical isomerisms are possible for this one. Now idralli, now the two geometrical isomers are possible for this one alva. Now what are the two geometrical isomerism possible for this one? It is the cis and the trans. Now which one is the cis and which one is the trans anta you comment box alli comment ಮಾಡಿ. Now the two geometrical isomerisms are possible for this one. It is the 1A 1B and 1B. ಈಗ ಕಾಮೆಂಟ್ ಬಾಕ್ಸ್ ಅಲ್ಲಿ ಈಗ ನೀವು ಏನು ಕಾಮೆಂಟ್ ಮಾಡಂದ್ರೆ ಸರ್ geometrical isomerism for A dash, geometrical isomerism for the B. Clear? Now these are the geometrical isomerism. Now which one is the cis and which one is the trans you have to identify. ಯಾಕಂದ್ರೆ I can say ಏನಾಗುತ್ತಂದ್ರೆ sometimes you may also have to practice ಅಲ್ವಾ. ನನಗೆ ಕಾನ್ಸೆಪ್ಟ್ ನಿಮಗೆ ಎಕ್ಸ್ಪ್ಲೇನ್ ಮಾಡಿದ್ದೀನಿ. So this will give the possible isomers, two possible geometrical isomers they have given. But ಅದರಲ್ಲಿ ನಿಮಗೇನು ಸ್ವಲ್ಪ that practice and at the same time you should feel I should also know. ಅದಕ್ಕೋಸ್ಕರನೇ I am making to say sir ನಿಮಗೇನು ಗೊತ್ತಿಲ್ಲ, why you are not saying I know this much I have explained, why I don't know which one is a cis and which one is a trans. I know, but you too want to also make to some practice alva. So comment box alli comment ಮಾಡಿ, so that I will also get to know that my students are what are practicing the are following my content, so that I will also be very happy while seeing your comments. Okay, next okay, A and B. Calculate the spin only, same magnetic moment of the, already we have seen they are repeatedly asking the questions. Now magnetic moment of the M3 plus aqueous atomic number Z, metal atomic number is 24. Now metal atomic number 24 andre yavadu? Chromium alva. Chromium electronic configuration yavadu? Chromium electronic configuration is 1s2, 2s2, 2p6, 3s2, 3p6, 4s1, 3d5 alva. 4s1, 3d5 andre this is up to argon. Clear? Now this is the variable oxidation, this is the electronic configuration outermost 3d5, but 3 electrons has been removed alva. 3 electrons has been removed. If the 3 electrons has been removed, now it will reach to the argon 3d3. No, in the 3d3 ಅಲ್ಲಿ ಎಷ್ಟು unpaired electrons ಇರುತ್ತೆ? 1 2 3 ಅಂದ್ರೆ 3 unpaired electron ಅಲ್ವಾ. n is equal to 3. magnetic moment formula ಏನು? under root n into n plus 2 Bohr magnetons. Clear? n value 3 ಅಂದ್ರೆ 3 into 3 plus 2 Bohr magnetons ಅಂದ್ರೆ root 15 Bohr magnetons ಅಲ್ವಾ. Now approximately it will get 3.84 or 3.74 or something you will get. Okay, next here write the IUPAC name of the complex. What is the complex? CO, cobalt, NH3 ammonia, amine 3. Now this is the IUPAC name of the complex. Now iga ಇಲ್ಲಿ ನೋಡಿ, this is triamine, trichloro, cobalt 3 because this is a neutral atom alva, neutral coordination sphere. This is a neutral coordination sphere. If there is any charges we can represent with the ion. Now here if it is any Cl, then this is a cationic sphere, then that is the anionic sphere alva. Now here this is the IUPAC name. ಯಾವುದು triamine trichloro cobalt 3 triamine tri cobalt 3 ಯಾಕಂದ್ರೆ amine is a neutral ligand. Its oxidation number is 0. Chlorido is a negative monodentate neutral ligand, monodentate negative ligand alwa, monodentate negative ligand. Adugoskaraನೆ its atomic number is -1. Now cobalt it is having the +3, oxidation number is +3. But now it is in the form of A3. It is in the form of A3 and the B3 type. This A3 and the B3 type, it will not show the geometrical isomerism. Of the cis and trans. This is very, very important. They are repeatedly asking in your boards. Okay? They will not show the cis and trans. What they will do? They will show the facial and the meridional. Nimdalma facial andre beauty parlor facial alla. Okay? Now this is a compound which will show the facial. Now facial andre 3 should be in the similar. Okay? 3 should be in the similar. But when it comes to the meridional, the 3 should be in the similar sides. 3 should be in the similar size. But when it comes to the meridional ಅಲ್ಲಿ Cl and the another Cl should be opposite to it. Okay? This is the 3D diagrams. While expressing in the 2D, it will make the very difficult for us. Okay? Next. Using the valency bond theory, now explain the geometry, hybridization and the magnetic moment of the repeated question of the VBT ಅಲ್ಲಿ we can expect ಒಂದು question. ಈಗ ನಿಮ್ಮ ಬೋರ್ಡ್ ಅಲ್ಲಿ ಒಂದು VBT question ಕೊಟ್ಟಿದ್ದೀರಂದ್ರೆ starting ಅಲ್ಲಿ in the 2 marks question, if you have seen the VBT question, just to choose that question and solve and write that question. ಏನಿಲ್ಲ, ಫಸ್ಟ್ ನ ಕಾಂಪ್ಲೆಕ್ಸ್ ನೋಡಿ, ಮೆಟಲ್ ಪಕ್ಕದಲ್ಲಿ ಲಿಗ್ಯಾಂಡ್ಸ್ ನೋಡಿ. ಆ ಲಿಗ್ಯಾಂಡ್ಸ್ ನ ವೀಕ್ ಫಿಲ್ ಲಿಗ್ಯಾಂಡ್ ಕೊಟ್ಟಿದ್ದೀರಾ, ಸ್ಟ್ರಾಂಗ್ ಫಿಲ್ ಲಿಗ್ಯಾಂಡ್ ಕೊಟ್ಟಿದ್ದೀರಾ. ಈಗ ನಿಮ್ಗೆ ಈಗ ವೀಕ್ ಫಿಲ್ ಲಿಗ್ಯಾಂಡ್ ಯಾವುದು, ಸ್ಟ್ರಾಂಗ್ ಫಿಲ್ ಲಿಗ್ಯಾಂಡ್ ಯಾವುದು ಈಗ ಗೊತ್ತಿಲ್ಲ ಅಂದ್ರೆ ಏನಾಗುತ್ತೆ ಆನ್ಸರ್? ವಿಬಿಟಿ ಆನ್ಸರ್ ಮೋಯೆ. ಯಾಕಂದ್ರೆ ವಿಬಿಟಿಯಲ್ಲೇ ಬೇಸಿಕೆ ಫಸ್ಟ್ ಸ್ಟ್ರಾಂಗ್ ಫಿಲ್ ಲಿಗ್ಯಾಂಡ್ ಯಾವುದು, ವೀಕ್ ಫಿಲ್ ಲಿಗ್ಯಾಂಡ್ ಯಾವುದು ಅದು ನಾ ನೆನಪಿಟ್ಕೋಬೇಕು. ಅದು ಗೊತ್ತಿಲ್ಲ ಅಂದ್ರೆ ಮೋಯೆ ಆಗುತ್ತೆ. ವಾಟ್ ಎವರ್ ದ ವಿಬಿಟಿ ಕಾನ್ಸೆಪ್ಟ್ ಯು ಆರ್ ಟ್ರೈಯಿಂಗ್, ಇಟ್ ವಿಲ್ ಬಿಕಮ್ ಟೋಟಲಿ ಗಾನ್. ಕ್ಲಿಯರ್? ನೌ ಈಗ ಕೋಬಾಲ್ಟ್ F6+3, F is the weak field ligand alwa. Fluorido is a weak field ligand. When the fluorido is a weak field ligand, cobalt it is having the oxidation number. Now cobalt Fe6-3. Clear? Now the cobalt oxidation number is a +3. Andre argon it is having the 3d6. Clear? 3d6 andre no, this is a weak field ligand alwa. 1 2 3 4 5 6 weak field ligand andre there is no pairing. Pairing ಆಗಲ್ಲ. No 4s ಮತ್ತೆ next pf 1 2 p. Now it can use the d also. 1 2 3 4. Now one F, another F. Now another F. Now this is another F. Total how many? 1 2 3 4 5 6. Andre this is S, this is 3 and this is 2. Now what is asking? Hybridization is the sp3d2. Now geometry, octahedral. Next what is asking? Magnetic nature or magnetic property. ಮ್ಯಾಗ್ನೆಟಿಕ್ ಪ್ರಾಪರ್ಟಿ ಈಸ್ ಈಕ್ವಲ್ ಟು ನಂಬರ್ ಆಫ್ ಅನ್ಪೇಡ್ ಎಲೆಕ್ಟ್ರಾನ್ಸ್ ಎಷ್ಟು 4 ಅಲ್ವಾ. ಇದರಲ್ಲಿ 4 ಅನ್ಪೇಡ್ ಎಲೆಕ್ಟ್ರಾನ್ ಇದೆ ಅಂದರೆ 4 ಅನ್ಪೇಡ್ ಎಲೆಕ್ಟ್ರಾನ್ ಇದೆ ಅಂದರೆ ದಿಸ್ ಈಸ್ ಅ ಪ್ಯಾರಾಮ್ಯಾಗ್ನೆಟಿಕ್. ನಾವು ಎನ್ ವ್ಯಾಲ್ಯೂ ಎಷ್ಟು ಅಂದರೆ 4. ವ್ಯಾಲ್ಯೂ ಎಷ್ಟು ಅಂದರೆ 4. ಕ್ಲಿಯರ್? ಡನ್. ನೆಕ್ಸ್ಟ್ between the titanium plus 4 and the titanium plus 3, which is more stable and why? Which is the more stable and the why? ಮತ್ತೆ ಇದರಲ್ಲಿ ಟೈಟಾನಿಯಂ ಪ್ಲಸ್ 4 ಮತ್ತು ಟೈಟಾನಿಯಂ ಪ್ಲಸ್ 3 ಅಲ್ಲಿ ಯು ಕ್ಯಾನ್ ವೆರಿ ಈಸಿಲಿ ಯು ಕ್ಯಾನ್ ಸೀರೋಣ ಟೈಟಾನಿಯಂ ಪ್ಲಸ್ 4 ಮತ್ತು ಟೈಟಾನಿಯಂ ಪ್ಲಸ್ 3. ವಾಟ್ ಇಸ್ ದ ಫಸ್ಟ್? ಮೊದಲನೇ ಏನು ಮಾಡಿ ಅಂದರೆ ಈಗ ಟೈಟಾನಿಯಂ ಪ್ಲಸ್ 4 ಮತ್ತು ಟೈಟಾನಿಯಂ ಪ್ಲಸ್ 3 ಈಗ ಈ ಥರ ಒಂದು ಕ್ವಶನ್ಸ್ ಕೊಟ್ಟಿದ್ದೀರ ಅಂದರೆ ಮೊದಲ ನೀವು ಏನು ನೋಡ್ಬೇಕಂದ್ರೆ ಅಟಾಮಿಕ್ ನಂಬರ್, ಫಸ್ಟ್ ದಟ್ ಎಲಿಮೆಂಟ್ಸ್ ಅಟಾಮಿಕ್ ನಂಬರ್ ನಿಮಗೆ ಗೊತ್ತಿರಬೇಕು. ಆಫ್ಟರ್ ದಟ್ ಬೈ ಲಾಸಿಂಗ್ ಇಟ್ಸ್ ಎಲೆಕ್ಟ್ರಾನ್ಸ್ ನಾವು ಚಾರ್ಜ್ ಈಗ ಪ್ಲಸ್ 4 ಅಂತ ಕೊಟ್ಟಿದ್ರೆ ಅಂದರೆ ಹೌ ಮೆನಿ ಎಲೆಕ್ಟ್ರಾನ್ಸ್? ಟೈಟಾನಿಯಂ ಪ್ಲಸ್ 4 ಹ್ಯಾಸ್ ಬಿನ್ ಲಾಸ್ಟ್, 4 ಎಲೆಕ್ಟ್ರಾನ್ಸ್ ಇಟ್ ಹ್ಯಾಸ್ ಲಾಸ್ಟ್ ಅಲ್ವಾ. ಮತ್ತೆ ಟೈಟಾನಿಯಂ ಪ್ಲಸ್ 3 ಹೌ ಮೆನಿ ಎಲೆಕ್ಟ್ರಾನ್ಸ್ ಇಟ್ ಹ್ಯಾಸ್ ಲಾಸ್ಟ್? 3 ಎಲೆಕ್ಟ್ರಾನ್ಸ್ ಇಟ್ ಲಾಸ್ಟ್ ಅಲ್ವಾ. ನೌ ಬೈ ದಟ್ ಯು ಹ್ಯಾವ್ ಟು ಸಿ now which one has been reached to the nearest noble gas element, which one has been reached to the or nearest any stable electronic configuration anta you have to see. Clear? Now ಈಗ ಟೈಟಾನಿಯಂ ಪ್ಲಸ್ 4 ಅಂತ ನೋಡಿ, ಟೈಟಾನಿಯಂ ಪ್ಲಸ್ 4. ಕ್ಲಿಯರ್? ಟೈಟಾನಿಯಂ ಪ್ಲಸ್ 4 ಮತ್ತೆ ಟೈಟಾನಿಯಂ ಪ್ಲಸ್ 3. ವಾಟ್ ಇಸ್ ದ ಅಟಾಮಿಕ್ ನಂಬರ್ ಆಫ್ ದ ಟೈಟಾನಿಯಂ ಪ್ಲಸ್ 4? 22. ಇದರಲ್ಲಿ ಅಟಾಮಿಕ್ ನಂಬರ್ ಎಷ್ಟು? 22. ಸ್ಕ್ಯಾಂಡಿಯಂ ಟೈಟಾನಿಯಂ ಅಲ್ವಾ. ಆರ್ಗಾನ್ 4s2 3d2. Clear? Now this is argon 4s2 3d2. Titanium general electronic configuration is this one, but titanium plus 3 alva. Now 2 electron 1 electron it has been lost. Now titanium plus 3 electronic configuration is argon 3d1. Titanium plus 4 electrons has been lost. Now its electronic configuration is argon d0. ಇದೆಲ್ಲ ನೋಡಿ, you only see and say me the answer. Now which one has been reached to the noble gas electronic configuration? Which one has not reached to the noble gas electronic configuration? The one which has been reached to the noble gas electronic configuration is a more stable. The one which is not reached to the noble gas electronic configuration is a not stable. Clear ಆಯ್ತಲ್ವಾ? ನಾವು ಇಲ್ಲ ನೋಡಿ, among the TiF4 and the Ti plus 3, TiF4 and the TiF4 and the Ti plus 3, titanium plus 4 and the titanium plus 3, which is more stable? Titanium plus 3 has been, no, it has reached to the noble gas electronic configuration. It has reached to the noble gas electronic configuration. Now it has reached to the noble gas electronic configuration. Adugoskarané this is more stable. Ti plus 4 is a more stable than the Ti plus 3. Okay, ಈ ತರ ಕ್ವಶನ್ಸ್ ಕೊಟ್ಟಿದ್ದಾರೆ ಅಂದ್ರೆ ಒಂದೇ ಒಂದು ನೆನಪಿಟ್ಕೊಳ್ಳಿ. What you have to remember? First you have to see the charge. ಈಗ ಆ ಚಾರ್ಜ್ ನೋಡ್ಕೊಂಡು how much charge, how many electrons it has been lost, Now next ಸೇಮ್ ತರನೇ ಈ ತರನೇ ಒಂದು ಕ್ವಶನ್ ಕೊಟ್ಟಿದ್ದಾರೆ ಅಂದ್ರೆ what I am asking, if titanium now ಈಗ ಟೈಟಾನಿಯಂ ಪ್ಲಸ್ 4 ಮತ್ತೆ ಟೈಟಾನಿಯಂ ಪ್ಲಸ್ 3, titanium plus 4 ಮತ್ತೆ titanium plus 3, which is a colored compound? Titanium plus 4 ಮತ್ತೆ titanium plus 3, which is a colored compound? What is the reason? ಒಂದೊಂದು ಸಾರಿ they can modify this question. ಏನು modify ಮಾಡ್ತಾರೆ ಅಂದ್ರೆ between the titanium plus 4 and the titanium plus 3, which is more stable and the why? ಈಗ ನಿಮಗೆ ಗೊತ್ತಾಯ್ತಲ್ವಾ? By losing the 4 electron, titanium has been reached to the noble gas electronic configuration. Adugoskarané this is more stable than the titanium plus 3. ಮತ್ತೆ titanium plus 4 ಮತ್ತೆ titanium plus 3 ಅಲ್ಲಿ which is a colored compound ಅಂತ ಕೇಳ್ತಾ ಇರಲ್ವಾ? Which is a colored compound? Titanium plus 3 is a colored compound. Titanium plus 4 is a colorless compound. ಯಾಕೆ? ಯಾಕೆ ಟೈಟಾನಿಯಂ +4 by losing the 4 electrons it has been reached to the d0 electronic configuration. ಈಗ d0 electronic configuration ಬಂದಾಗ d0 ಮತ್ತೆ d10 are the colorless ಅಲ್ವಾ, colorless. ಅದಕ್ಕೋಸ್ಕರನೇ d4 is a ಟೈಟಾನಿಯಂ +4 is a colorless ಮತ್ತೆ ಟೈಟಾನಿಯಂ +3 is a colored. ಯಾಕಂದ್ರೆ ಡ್ಯೂ ಟು ದ ಪ್ರೆಸೆನ್ಸ್ ಆಫ್ ದ ಅನ್ಪೇಡ್ ಎಲೆಕ್ಟ್ರಾನ್, ಡ್ಯೂ ಟು ದ ಪ್ರೆಸೆನ್ಸ್ ಆಫ್ ದ ಅನ್ಪೇಡ್ ಎಲೆಕ್ಟ್ರಾನ್ dd ಟ್ರಾನ್ಸಿಷನ್ ಆಗುತ್ತೆ, dd ಟ್ರಾನ್ಸಿಷನ್ ಆಗುತ್ತೆ. ಅಂದ್ರೆ ಈಗ here due to the presence of this, now let assume here the electron is in the ground state, electron is in the ground state. By observing this electron, by observing this some energy, now this electron will be excited to the higher energy level. Now ಇದರಲ್ಲಿ ಎಷ್ಟು ಎನರ್ಜಿ ಅಬ್ಸರ್ವ್ ಮಾಡಿದೋ while coming to the ground state, the same energy should be released, ಈಗ this energy will be fall under the visible region, due to that we'll get the color, clear. But ಈಗ d0 ಅಲ್ಲಿ there is no any electrons only, when there is no any electrons, how it can be excited? There is no electrons only. Then when there is no electrons, there is no dd transition is possible, there is colorless. ಈಗ d10 ಅಲ್ಲಿ ನೋಡಿ, d10 ಅಲ್ಲಿ all the electrons are completely filled alwa. If you take the octahedral complex, now this is for the octahedral complex, generally I am explaining. Now for the octahedral and the tetrahedral, both it will be the filled electrons only. Again, if you have given the energy, now already the upper energy level Eg for the octahedral, 2Tg for the tetrahedral, all are it has filled alwa. There is no any chance to accept the electron, andre idralli also d10 transition is not possible. ಈಗ transition, when it is transition is not possible, colorless. Okay, colorless. Done. Next, sometimes they may modify the question also. ಒಂದೊಂದು ಸಾರಿ ಈಗ ಏನು ಮಾಡ್ತಾರೆ ಅಂದರೆ ಕ್ವಶನ್ನ ಮಾಡಿಫೈ ಮಾಡಿ ಕೊಡ್ತಾರೆ. ಓಕೆ, ಯು ಹ್ಯಾವ್ ಟು ಬಿ ವೆರಿ ಕೇರ್ಫುಲ್. ಯಾವ ಥರ ಕ್ವಶನ್ ಅಂತ ಕೇಳ್ತಾ ಇದ್ರು, ಇನ್ ವಾಟ್ ವೇ ದೇ ಆರ್ ಆಸ್ಕಿಂಗ್. ಓಕೆ, ಯು ಹ್ಯಾವ್ ಟು ಬಿ ವೆರಿ ಕೇರ್ಫುಲ್. ನೆಕ್ಸ್ಟ್ ಇನ್ನೊಂದು, ನೆಕ್ಸ್ಟ್ ಅನದರ್ ಒನ್. ಸಿ ದಿಸ್ ಮೆನಿ ಕ್ವಶನ್ಸ್ ಆನ್ ದ, ಐ ಥಿಂಕ್ ಆಲ್ರೆಡಿ ವಿ ಹ್ಯಾವ್ ಡನ್ ದಿಸ್ ಕ್ವಶನ್, ಐ ಥಿಂಕ್ ಸೊ. ಸ್ಟಾರ್ಟಿಂಗಲ್ಲೇ ಮಾಡಿದ್ದೀವಲ್ವ ಇನ್ನೊಂದು ಕ್ವಶನ್. ದಟ್ ಈಸ್, ದಿಸ್ ಈಸ್ ಸೈನೈಡ್. ಬಟ್ ಇದರಲ್ಲಿ ಏನು ಕೊಟ್ಟಿದ್ರು, ಇದರಲ್ಲಿ ಕ್ಲೋರಿನ್ ಕೊಟ್ಟಿದ್ರಲ್ವ, ಸೇಮ್. ಅದರಲ್ಲಿ ಸೈನೈಡ್, ಇದರಲ್ಲಿ ಕ್ಲೋರಿನ್. ಕ್ಲೋರಿನ್ ಸೇಮ್, ನಿಕೆಲ್ +2 ಅಂದರೆ ಆರ್ಗಾನ್ 3d8. ಬಟ್ ದ ಕ್ಲೋರಿನ್ is a weak field ligand alwa. This is the weak field ligand. When the chlorine is a weak field ligand, then there is no any pairing happen. When there is no pairing happen, now here, now what is the hybridization? Tetrahedral. Now here the one chlorine, here the one chlorine, here the one chlorine, here the one chlorine. Hybridization is sp3. Geometry is tetrahedral. Now magnetic property is paramagnetic. ಯಾಕೆ? ಡ್ಯೂ ಟು ದ ಅನ್ಪೇಡ್ ಎಲೆಕ್ಟ್ರಾನ್ಸ್. ಈಗ ಡ್ಯೂ ಟು ದ ಪ್ರೆಸೆನ್ಸ್ ಆಫ್ ದಿಸ್ ಅನ್ಪೇಡ್ ಎಲೆಕ್ಟ್ರಾನ್, ದಿಸ್ ಇಸ್ ದ paramagnetic. Okay, next. Write the IUPAC name of this complex and explain the linkage isomers with the example. Clear? No. ಈಗ ಈ ಕಾಂಪ್ಲೆಕ್ಸ್ಗೆ IUPAC ನೇಮ್ ಏನಂದ್ರೆ cobalt, amine and the aqua, chlorine and the Cl2. In the coordination sphere ಅಲ್ಲಿ we are having the three types of the ligands alwa. Then we have to give the naming according to its alphabetical order. Now this is the amine and this is the aqua. ಅದಕ್ಕೋಸ್ಕರನೇ ಟೆಟ್ರಾ ಅಮೈನ್ aqua chloro cobalt, oxidation number of the cobalt is +3, and the chloride now this is the IUPAC name of this complex. IUPAC name of this complex. What is the linkage isomer anta kelta idaro? Linkage isomer andre enadre coordination compounds having the same molecular formula. Coordination compounds, these coordination compounds having the same molecular formula but differ in the mode of attachment, of the ligand. ಈಗ ಲಿಂಕೇಜ್ ಐಸೋಮರಿಸಮ್ ಅಲ್ಲಿ ಸೇಮ್ ಫಾರ್ಮುಲಾ ಇರಬೇಕು ಬಟ್ ಲಿಗ್ಯಾಂಡ್ ಅಟ್ಯಾಚ್ಮೆಂಟ್ ಆಫ್ ದ ಲಿಗ್ಯಾಂಡ್ ಟು ದ ಮೆಟಲ್, ಆಟಮ್ ಆರ್ ಅಯಾನ್ ಥ್ರೂ ಎ ಡಿಫರೆಂಟ್ ಆಟಮ್. ಇಲ್ಲಿ ನೋಡಿ, ಹಿಯರ್ ದಿಸ್ ಇಸ್ ಅ ಸೆಂಟ್ರಲ್ ಆಟಮ್, ಕೋಬಾಲ್ಟ್ ಇಸ್ ಅ ಸೆಂಟ್ರಲ್ ಆಟಮ್. ನೌ ಹಿಯರ್ in the nitro group now N has been attached to the cobalt, but from this one, in this, oxygen has been attached. Same molecular formula, but ligand attachment is different to the different atom. In the first one it is from the nitrogen end, and the second one from the oxygen end. This we call it as a linkage isomers. Okay, next write the 𝐊𝐻 structures of the sucrose. Now this is the sucrose is not the reducing sugar alva. Now this is the structure of the 𝐊𝐻 structure of the sucrose. ಇನ್ನೇನು ಪೆಟ್ಕೋಬೇಕು, this structure you have to remember. Sucrose, ಈಗ biomolecules ಅಲ್ಲಿ they can ask the 𝐊𝐻 structures of the sucrose, lactose. Okay, now sometimes they may ask the structure of the glucose and the structure of the fructose. Okay, next, now this is the 𝐊𝐻 structure of the sucrose. ಒಂದೇ ನೆನ್ಪಿಟ್ಕೊಳ್ಳಿ. ನಾವು ಈಗ sucrose structure or 𝐊𝐻 structure anta kelidire andre one should be the 6-membered ring and one should be the 5-membered ring. Clear? Next, what are the hormones? Give an example. What are the hormones? Give some examples anta kelta idralva. What are the hormones and give the examples. Hormones, chemical substance that act like messenger molecules in the body. Now hormones andre ಏನು? The chemical substance that act like an messenger molecules in the body is known as the hormones. Give an examples. Amino acid derivatives, peptide linkages, lipid derivatives. These are the examples for the hormones. Clear? These are the examples for the hormones. Next, now explain the Clemmensen reduction with an example. ಈಗ Clemmensen reduction with the example. Clemmensen reduction ಏನಾಗುತ್ತಂದ್ರೆ, Clemmensen reduction ಅಲ್ಲಿ Clemmensen reduction and the Wolff-Kishner reduction both are Clemmensen reduction, Wolff-Kishner reduction, both are the what it will do andre carbonyl compounds will be converted into the hydrocarbons. Carbonyl compounds of the aldehydes are the ketones will be converted into the hydrocarbons. Now with the example anta kelta idiralla Clemmensen reduction. What is the Clemmensen reduction? The carbonyl compound with the carbonyl compound in the presence of zinc amalgam, zinc and the Hg, zinc amalgam in the presence of HCl, aldehydes are ketones will be converted into the hydrocarbons, converted into the alkenes, ಇಲ್ಲಿ ನೋಡಿ here now one carbonyl compound ನಾನು ತಗೊಂಡಿದ್ದೀನಿ. this is a one carbonyl compound in the presence of zinc amalgam, HCl. Clear? Now here the HCl we are having the H plus, now oxygen ಮೇಲೆ lone pair ಇತ್ತಲ್ವಾ, now this lone pair will abstract this proton, now oxygen ಮೇಲೆ ಏನು ಚಾರ್ಜ್ ಬರುತ್ತೆ, ಪಾಸಿಟಿವ್ ಚಾರ್ಜ್ ಬರುತ್ತಲ್ವಾ. now to stabilize this positive charge, now this bond pair of electron has been shifted towards the which one, oxygen, then COH bond. now here we will get the positive charge, now here the zinc we are having alva, now zinc by readily lost the 2 electrons, ಯಾಕಂದ್ರೆ zinc will readily oxidize alva. now these 2 electrons has been gained by this positive charge and will get the OH, and the here will get the negative charge by gaining the 2 electrons, now it will get the negative charge. now in the solution we are having the positive H plus ions, now this H plus ion will go and attack here and will get the COH, now here the will get the H plus. okay, again the solution we are having the H plus, now oxygen, this lone pair will abstract this proton, now it will form the oxonium ion, now oxonium ion, H2O is a good leaving group, by taking the bond pair of electrons as a H2O it will be eliminated. now after the H2O it is eliminated, carbon ಮೇಲೆ ಏನು ಚಾರ್ಜ್ ಬರುತ್ತೆ, ಪಾಸಿಟಿವ್ ಚಾರ್ಜ್ ಬರುತ್ತಲ್ವಾ. zinc excess ಇರುತ್ತಲ್ವಾ, zinc it is having in the solution, now again zinc it will readily lose the 2 electrons, and it will gain by this carbon and it will get the negative charge. okay, now again in the solution we are having the H plus, now that H plus it will be attacked by this negative charge and will get the CH2, andre alkane we have came alva. if you have taken the aldehyde, it will convert into CH3. if you have taken the ketone, it will convert into CH2. clear? in the presence of carbonyl compound in the presence of zinc amalgam, in the presence of HCl, aldehydes or ketones will be converted into the alkanes. Aldehydes or ketones are converted into the aldehydes. This is the mechanism. Then clear? Next question. now what is the action of the bromine in the ethanoic acid on the anisole? give the equation. ಈಗ anisole ಅಲ್ಲಿ Br2 in the presence of acetic acid, ethanoic acid ಅಂದ್ರೆ ಏನು, acetic acid. this is anisole. now this is the anisole alva, anisole in the presence Br2 in the presence of acetic acid, or ethanoic acid. now this anisole, what it will do, this is the ring activating group, ring activating clear? ring activating group alva, ಯಾಕಂದ್ರೆ ಆಕ್ಸಿಜನ್ ಮೇಲೆ ಲೋನ್ ಪೇರ್ ಇದೆಯಲ್ವಾ, ಲೋನ್ ಪೇರ್ it will be given to the ring, andre it will activate the ring activating group, it will activate the ring yet ortho and para positions. now ಈಗ anisole in the presence of Br2 in the presence of acetic acid ಏನಾಗುತ್ತಂದ್ರೆ now anisole is a ring activating group alva, ring activating due to the presence of this lone pair. Here we'll get the negative charge, again this negative charge will be delocalized, again this pi bond will be delocalized here. Andre here in the anisole alli now what are the charges we'll get, what are the when it is in the delocalization, when it is participated in the delocalization, now the charges we'll get here now at the negative charge at the ortho, para and the ortho and the para directing group alva, adakoskarane methoxy group will increase the electron density at the ortho and the para position. Clear? Now Br2 in the presence of acetic acid, we'll get the Br electrophile. Now this Br electrophile, we are having the two conditions to can attack at the ortho position, can attack at the para position. But bromine due to the bulky group or bulky size, yakandre halogens yavadu chlorine, bromine, iodine alva. Now down the group ಏನಾಗುತ್ತೆ, size increases alva, size increases. Now size increases andre due to the higher size, due to the bulky size of the bromine, bromine will attack at the para position. Idralli if it is attacked, now this two will be repel, yakandre oxygen ಮೇಲೆ lone pair ಇದೆಯಲ್ವಾ, bromine ಮೇಲೆ ಇದು lone pair ಇರುತ್ತಲ್ವಾ. ನಾವು bromine ಮೇಲೆ ಎಷ್ಟು lone pair ಇರುತ್ತೆ, halogens are having the 3 lone pairs ಅಲ್ವಾ. ನಾವು bromine ಮೇಲೆನೂ lone pair ಇರುತ್ತಲ್ವಾ, due to that lone pair repulsion, now the compound will become unstable. To make the stable ಅದಕ್ಕೋಸ್ಕರನೇ ಏನು ಮಾಡಬೇಕಂದ್ರೆ bromine will be attacked at the para position, Clear? Now this is the answer. What is the action of the bromine in the ethanoic acid on the anisole? Give the equation. Clear? So this is the equation. Next, now acetaldehyde ಮತ್ತೆ acetone, the acetaldehyde is more reactive than the acetone towards the nucleophilic addition reaction. Give the reason. This is very, very important. Now they can change the question in the different manners also. Yakandre ನೋಡಿ, this is aldehyde. Now first ನಾನು explain ಮಾಡ್ತೀನಿ, ಆಮೇಲೆ I will write the theory of this one. CH3 C double bond OH. Okay, CH3 C double bond OH. Now nucleophilic addition, let assume HCN. Now first, now oxygen lone pair will abstract this one. Now here CH3 COH, because here the positive charge will get, this will be going alva. Now here H, now here the positive charge, here this positive charge. ಈಗ ಇದರಲ್ಲಿ ಪಾಸಿಟಿವ್ ಚಾರ್ಜ್ how much strong this positive charge it is present, that much fast nucleophile will be attacked, the nucleophile will be attacked. Clear ಆಯ್ತಲ್ವಾ? ನಾವು ಇದರಲ್ಲಿ ಎಷ್ಟು ಜಾಸ್ತಿ ಚಾರ್ಜ್ ಇರುತ್ತೋ, how much strong positive charge ಇರುತ್ತೋ, that much strong this nucleophile will come and attack. ಈಗ ಈ ಕಾನ್ಸೆಪ್ಟ್ ನಿಮಗೆ ಅರ್ಥ ಮಾಡೋಕ್ಕೆ, to clear this concept, ನಿಮಗೆ GOC ಅಲ್ಲಿ ಸ್ಟ್ರಾಂಗ್ ಇರಬೇಕು. ಏನಿರಬೇಕು? ಸ್ಟ್ರಾಂಗ್ ಇರಬೇಕು. ಈಗ GOC ಅದು ಫಸ್ಟ್ ಇಯರ್ ಅಲ್ಲಿ ಬರುತ್ತಲ್ವಾ? GOC will comes in the first year only. ಬಟ್ ಈಗ if you are not perfect in the GOC, ಏನಾಗುತ್ತೆ, ದಿಸ್ ಕ್ವಶನ್ ವಿಲ್ ಬಿಕಮ್ ಮೋಯೆ ಆಗುತ್ತೆ. ಯಾಕೆ here you have to know what are the plus I groups, what are the minus I groups, which one will stabilize the carbocation, which one will destabilize the carbocation. Clear? Now here ಸಾರಿ ನೋ ಇಲ್ಲಿ ನೋಡಿ ಈಗ this lone pair has been taken from the HCN ಅಂದ್ರೆ it will be dissociated to the H plus CN minus ಅಲ್ವಾ. this is the nucleophile, this is the electrophile. now ಈಗ ಇದರಲ್ಲಿ ಜಾಸ್ತಿ ಚಾರ್ಜ್ whenever the charge is more the nucleophilic addition will be happen. now ಇಲ್ಲಿ ನೋಡಿ this CH3 is a plus I group ಅಲ್ವಾ. plus I group ಅಂದ್ರೆ ಏನು? electron releasing group. ಈಗ electron releasing group now tendency to give the electrons will be more alwa. tendency to give the electrons will be more. ಈಗ tendency to give the electrons more andre now this is carbocation, it is a electron deficient or electron sufficient. already this carbon should form the 4 bonds alwa. carbon valence is 4, carbon can form the 4 bonds. idralli only 3 bonds idi alwa. andre this carbocation is less stable. ಈಗ carbocation less stable andre it needs the electrons, but here the group attached here it is a CH3. here the group attached here is the CH3. now CH3 ಏನು ಮಾಡುತ್ತೆ? now this will give the electrons alwa. when it is giving the electrons, now positive charge capacity is decreasing. it is decreasing. ಈಗ positive charge capacity decrease ಆಗದಾಗ now why it will attract the nucleophile? it will not attract alwa. clear? now next acetone ನೋಡಿ. clear? acetone na no it is H plus, now it is attracted, now CH3. now directly I am written, don't get confused. now ಇಲ್ಲಿ ನೋಡಿ now ಇದರಲ್ಲಿ ಎಷ್ಟು ಪ್ಲಸ್ ಐ ಗ್ರೂಪ್ಸ್ ಇದೆ? 2 ಪ್ಲಸ್ ಐ ಗ್ರೂಪ್ಸ್ ಇದೆಯಲ್ವಾ. 2 ಪ್ಲಸ್ ಐ ಗ್ರೂಪ್ಸ್. now ಈಗ 2 ಪ್ಲಸ್ ಐ ಗ್ರೂಪ್ಸ್ ಅಂದ್ರೆ ಏನು? what is the meaning of the plus I groups? electron releasing group alwa. electron releasing group ಏನು ಮಾಡುತ್ತೆ? it will give the electrons to the electron deficient species. ಈಗ electron deficient species ಗೆ electron ಕೊಡಿದಾಗ ಏನಾಗುತ್ತೆ? now positive charge on this carbon it will get less. clear? now the positive charge on this carbon when it is getting less, now attack of this nucleophile ಏನಾಗುತ್ತೆ? attack of this nucleophile will become, the rate or addition of this nucleophile will become less. ಯಾಕಂದ್ರೆ here the charge or power of this cation has been decreased. ಈಗ power of this cation has been decreased ಅಂದ್ರೆ nucleophile attack will become less. clear? ಮೊದಲನ first what you have to see ಅಂದ್ರೆ first you have to know the what is the plus I effect and what is the minus I effect. what is the plus I effect, what is the minus I effect, which groups will stabilize the carbocation, which groups will destabilize the carbocation. clear? aduna you have to remember. clear? now ಈಗ ನಾನು ಸೈಡ್ ಆಗಿ for this concept ಗೆ ಸೈಡ್ ಆಗಿ ನಿಮಗೆ ಎಕ್ಸ್ಪ್ಲೇನ್ ಮಾಡ್ತೀನಿ. see carbocation stability order, carbocation stability. now plus I groups increases the stability of carbocation. okay? minus I groups decreases the stability of carbocation. okay? now ಇದೊಂದು ನೆನಪಿಟ್ಕೋಬೇಕು. okay? clear? now ಈಗ ನ್ಯೂಕ್ಲಿಯೋಫಿಲಿಕ್ ಅಡಿಷನ್ ಅಲ್ಲಿ ಕಾರ್ಬೋಕ್ಯಾಟಯನ್ ಚಾರ್ಜ್ ಜಾಸ್ತಿ ಇರಬೇಕಲ್ವಾ. ಈ ಕಾರ್ಬೋಕ್ಯಾಟಯನ್ ಚಾರ್ಜ್ ಜಾಸ್ತಿ ಇದೆ ಅಂದ್ರೆ ನಾವು ನ್ಯೂಕ್ಲಿಯೋಫಿಲಿಕ್ ಅಡಿಷನ್ ವಿಲ್ ಆಲ್ಸೋ ಬಿ ವೆರಿ ಫಾಸ್ಟ್. ಕ್ಲಿಯರ್? ನ್ಯೂಕ್ಲಿಯೋಫಿಲಿಕ್ ಅಡಿಷನ್ ವಿಲ್ ಬಿ ಆಲ್ಸೋ ವೆರಿ ಫಾಸ್ಟ್ ಅಂಡ್ ದ ಮೋರ್ ಇಟ್ ವಿಲ್ ಬಿ ರಿಯಾಕ್ಟೆಡ್ ಅಲ್ವಾ. ವಾಟ್ ಇಟ್ ಈಸ್ ಆಸ್ಕಿಂಗ್? ಸಿ ಹಿಯರ್ CH3COH in aldehyde now aldehyde due to the presence of only one methyl group or one plus I group. now charge of carbocation is higher than the higher than the acetone, so that higher than the acetone, so that acetaldehyde is more reactive. Acetaldehyde is more reactive than the acetone. Clear? Than the acetone. ಇಲ್ಲಿ ನೋಡಿ CH3, C double bond O H. Now here after taking the H place, now CH3, C OH, H. This positive charge should be, strong. ಈಗ ಜಾಸ್ತಿ ಪಾಸಿಟಿವ್ ಚಾರ್ಜ್ ಇದೆ ಅಂದರೆ ನಾವು ಏನಾಗುತ್ತೆ ಸೈನೈಡ್, ಇಟ್ ವಿಲ್ ಟೇಕ್ ದ ಸೈನೈಡ್ ವೆರಿ ಫಾಸ್ಟ್ಲಿ. ಓಕೆ, ನೆಕ್ಸ್ಟ್ ಎಸಿಟೋನಲ್ಲಿ ನಾವು ಇಟ್ ವಿಲ್ ಟೇಕ್ ದ CH3, COH. ನಾವು ಇದರಲ್ಲಿ ಪಾಸಿಟಿವ್. ನಾವು ಡ್ಯೂ ಟು ದ ಪ್ರೆಸೆನ್ಸ್ ಆಫ್ ದಿಸ್ ಪ್ಲಸ್ ಐ ಮತ್ತು ಈ ಪ್ಲಸ್ ಐ, ನಾವು ದಿಸ್ ಪ್ಲಸ್ ಐ ಆ್ಯಂಡ್ ದಿಸ್ ಪ್ಲಸ್ ಐ, ನಾವು ಏನಾಗುತ್ತೆ ದಿಸ್ ಈಸ್ ಅ ಸೈನೈಡ್ ಅಲ್ವಾ, ಸೈನೈಡ್ ಮೈನಸ್. ನಾವು ಈಗ ಡ್ಯೂ ಟು ದ ಪ್ರೆಸೆನ್ಸ್ ಆಫ್ ದಿಸ್ ಪ್ಲಸ್ ಐ ಏನಾಗುತ್ತೆ, ದಿಸ್ ವಿಲ್ ಗಿವ್ ದ ಎಲೆಕ್ಟ್ರಾನ್ಸ್ ಟು ದಿಸ್ ಕಾರ್ಬೋಕ್ಯಾಟಯನ್. Now when these two are giving the carbocation, now this carbocation charge or power of this carbocation will become less, and this is this reactor. Okay, now this is a concept for the addition reaction. Next, how the anisole react with the acetyl chloride in the presence of anhydrous AlCl3. Write the equation for this one. Now anisole reacting with the acetyl chloride in the presence of anhydrous AlCl3. Now acetyl chloride in the presence of anhydrous AlCl3, this is the Friedel-Crafts acylation. Now this we have studied in the aromatic electrophilic substitution reaction in the hydrocarbons. Clear? Now first anisole. This is the anisole alwa. This is the anisole. Okay, anisole. Now just now I have said alwa, anisole it will be increase the electron density at the ortho and the para positions, like this. Now the negative charge, here the positive, here the positive. Again this negative charge will be delocalized and this pi bond will be delocalized here. Now here the negative charge, here the pi bond, double bond, O positive, and this is CH3. Okay, again this negative charge will be delocalized and this pi bond will be delocalized here. Here the negative charge, here the double bond, here the O positive, and here the CH3. Okay, now here the double bond, here. Now again this negative charge will be delocalized and the pi bond will be delocalized here. Now okay, now you can notice alva. Now where you have seen the charging, charges. Now one at ortho position, one para position, one ortho position. It is increasing the electron density at the ortho and para positions alva. Now here acetyl chloride, now in the presence of anhydrous AlCl3, this is the acetyl chloride in the presence of anhydrous AlCl3. Now this AlCl3 is a Lewis acid. Lewis acid andre ಏನು? One which accept the electrons. One which accept the electrons. The one which accept the electrons are known as the Lewis acid alva. Now how the AlCl3 will accept the Lewis electrons andre? Now this is nucleus, first shell, second shell, third shell. Now atomic number of the Al is 13 alva, 13. Andre this is 1s2, 2s2, 2p6. This is 3s2, 3p1 alva, 3p1. Matte 3d empty orbital also it is there alva. Now due to the presence of this empty p orbital and the d orbital, due to the presence of this empty p and d, due to the empty presence of this p orbital and the d orbital, Lewis acid will accept the electrons. Clear? That's the reason it is acting as a Lewis acid. Now here it will take the electrons. Lewis acid chlorine mele 3 lone pairs irutalva, then it will become the CH3, C double bond O. Now chlorine mele positive charge. Now AlCl3. Now chlorine mele Now this is Cl positive. Now chlorine mele positive charge is unstable. Now this is a given. Now this is a electrophile has been generated. Now this electrophile will be attacked at the ortho position and the para position. Now this electrophile will be attacked at the ortho position or para position. This is at the ortho position. This is ortho substituted. Now when it is substituted at the para position. Okay. Now these two products we will get. Clear? Now how the anisole react with the acetyl chloride in the presence of anhydrous AlCl3? Write the equation for this equation. First anisole will give the ortho and para directing group. Now here this is the aromatic electrophilic substitution reaction. Now anhydrous AlCl3 directly will act and it will give the electrophile. Electrophile will be attacked at the ortho position and the para position. We attacked at the ortho and the para position. Clear? Next question. Next question is explain the preparation of the carboxylic acid. Explain the preparation of the carboxylic acid from the Grignard reagent. Give the reason. Now how we can prepare the carboxylic acid? How we can prepare the carboxylic acid from the Grignard reagent? Grignard reagent in the carboxylic acid ಹೆಂಗ್ prepare ಮಾಡಬಹುದು ಅಂತ ಕೇಳ್ತಾ ಇದ್ರಲ್ವಾ. ಇಲ್ಲಿ ನೋಡಿ, here Grignard reagent. What is the Grignard reagent? RMgX. RMgX is the Grignard reagent. RMgX is the Grignard reagent ಅಲ್ವಾ. ಇಲ್ಲಿ ನೋಡಿ, most of the time carbon will show the positive charge, but when it is attached to the metal, carbon when it is attached to the metals, group 1 and the group 2 elements readily lost the electrons to attain noble gas electronic configuration. To attain the noble gas electronic configuration. Again, noble gas electronic configuration attend ಮಾಡೋಕೆ lithium, sodium, potassium, rubidium, cesium. Now ಇದರಲ್ಲಿ beryllium, magnesium, calcium, strontium, barium. This will readily lose the 2 electrons. This will readily lose the 1 electrons. When these readily lose the electrons, these metals will readily lose the electrons and will stay in the electropositive nature. By losing the 1 electron, it reaches to the noble gas electronic configuration. Group 2 alkaline earth to metal, by losing the 2 electrons, it will reach to the noble gas electronic configuration. ಅದಕ್ಕೋಸ್ಕರನೇ group 1 ಮತ್ತೆ group 2 elements readily stable. These are readily lost the electrons and more stable in the electropositive nature. ಅದಕ್ಕೋಸ್ಕರನೇ metal it is in the positive nature and the alkali it is in the negative. Alkali it is in the negative in the Grignard reagent. Clear? Metal in the Grignard reagent. Now how we can prepare the carboxylic acid from the Grignard reagent? Now by taking the solid CO2. By taking the CO2, what we'll get? We'll get the in the presence of dry ether and the H2O, heating and the H2O will get the RC double bond O H. How? We'll see now mechanism. Now C double bond O. Now this is a CO2. Now RMgX. Clear? Now here RMgX, here oxygen it is a more electronegative. Now double bond, oxygen will get the negative charge. Now this carbon will get the positive charge. RMgX. Now alkali it is more electronegative than the metal, because the metals will more stable in the electropositive nature alva. ಅದಕ್ಕೋಸ್ಕರನೇ this is negative and this is the positive. Now this positive will go and attack here. Now this negative will go and attack here. Clear? Now here double bond O, here this is R. Now OMgX, OMgX. Now upon hydrolysis and the heating, now break the double bond here, put the one hydrogen and put the OH here. Because why? Metals will exist in the electropositive nature alwa. If it is having a positive, H plus and the OH minus. Now this OH minus will go and attack to the Mg, H plus will go and attack to the oxygen. Clear? Now by that what we get? C double bond OH. Now by this carboxylic acid has been derived alwa. Carboxylic acid has been prepared by the Grignard reagent with the CO2. By taking the CO2, we can prepare the Grignard reagent. Sorry, we can prepare the carboxylic acid with the by taking the CO2. Clear? Next. How the anisole react with the bromine in the ethanoic acid? Write the chemical equation for the. I think already we have seen this. Question. Already we have seen this question alwa. Now how it is reacting? Br2. I think two times the questions has been came repeated, I think so. Now in the presence of Br2, in the presence of ethanoic acid, what we are getting? Br. Clear? This is the answer. Next question. Explain the Schwarz reaction with the example. Now what is the meaning of the Schwarz reaction? Now explain the Schwarz reaction with the example. The Schwarz reaction alli ಏನilla, alkali chlorides or bromides reacts with the metallic fluorides. Metallic fluorides andre ಏನು? Fluoride is attached to the metal. Alkali chlorides and the alkali bromides andre it has chlorides and the bromides has been attached to the alkali group. Alkali R CH3 or C2CH3. Okay, clear? Now here bromides react with the metallic fluorides such as AgF, Ag2F2, COF2 from the alkali fluorides and to form the alkali fluorides. ಈಗ alkali chloride ಇದರಲ್ಲಿ chloride X, either it may be the Cl, either it may be the Br, either it may be the Cl or either it may be the Br with AgF, metal fluoride. With the metal fluoride, what we are getting? The alkali fluoride and we are getting the AgX. This is known as the Schwarz reaction. Clear? Next. What is the action of the ammonia on the benzoic acid? Write the equation. What is the action of the ammonia on the benzoic acid? Write the equation. Clear? Now this is the benzoic acid alwa. This is the benzoic acid. Now this is the ammonia. Clear? Benzoic acid and this is the ammonia. Now here first ammonia, what it will do? This is the acidic hydrogen alwa. Readily it will take and it will form the ammonium benzoate. Upon heating, H2O has been eliminated and it will form the benzamide. Clear? It will form the benzamide. Write the products formed when the acetaldehyde react with the following: hydroxylamine and the hydrogen. Onde needbetkolnana, just when they have this type of the given. Now when acetaldehyde is reacting with the hydroxylamine, we'll get the oxime. Now when it is reacting with the hydrazine, we'll get the hydrazone. How andre hengandre illi nodi, first A. Now here A alli CH3 C H C double bond O. Clear? Now this is the acetaldehyde alwa. Now hydroxylamine. Now write in this manner: hydroxylamine. Now just eliminate the H2O. just to eliminate the H2O. By eliminating the H2O, what will get? CH3, CH double bond NOH, NOH. Now this is the oxime. Now this is the oxime. Clear? Now with the hydrazone, with the hydrazine, with the B. Here with the B kottidare andre CH3, CH double bond O plus hydrazine NH2, NH2. Hydrazine in the presence of the base will give the Wolff-Kishner reduction. Okay. Now here eliminate the H2O. Eliminate the H2O. Now we'll get the CH3. Now CH. Now double bond N and the NH2. NH2. Now this is a hydra. So this is a hydra. So clear? Now one is a oxime, one is a hydra. So now when the acetaldehyde react with the hydroxylamine, we'll get the oxime. It will when it is reacting with the hydrazine, when it is reacting with the hydrazine, we are getting the hydrazone. Hydrazone. Clear? Next, explain the following reaction. Explain the following reaction. Now A plus B in the presence of zinc oxide and the chromium oxide, it is giving the ethanol. Now what is the A and B is asking. But here onde ondu nenpetkobeku, zinc oxide and the chromium oxide, when it is reacting at the 200 degrees at the high pressure and the high temperature, carbon monoxide in the presence of H2 gives the methanol. Now carbon monoxide react with the H2 under certain condition. What is that certain condition? Carbon monoxide reacting with the H2 under certain condition. What is that certain condition? High pressure irbeku, high temperature irbekalva. Then what we are getting? Then what we are getting? Methanol we are getting. Clear? Methanol we are getting. Next. Next. Haloalkenes react with the KCN to form the alkali cyanide as a main product, while AgCN forms a isocyanide as a chief product. Why? Iga haloalkenes when it is reacting with the KCN, this is some haloalkane reacting with the KCN, it is forming the alkali cyanide. Now, haloalkane when it is reacting with the AgCN, it is forming the isocyanide. This is a isocyanide, that is a cyanide. Why? Give the reason anta kelta idralva. Now see. Here in the KCN, now answer, when KCN is reacted with alkali halide, KCN is reacted with the alkali halide, when the KCN is reacted with the alkali halide, alkali cyanide is main product due to ionic nature of KCN, due to the ionic nature of the KCN. Now carbon and the nitrogen both are having donating sites. Iga nitrogen is also having the donating sites. Carbon is also having the donating sites. But carbon single bond carbon or carbon bond carbon is more stable than the nitrogen so attack will be from the carbon end. Attack will be from the carbon end, not from the nitrogen end. Now in that sense, in the presence of AgCN, in the presence of the AgCN ಏನಾಗುತ್ತಂದ್ರೆ, in the presence of the AgCN, it is a covalent in the nature. It is a covalent in the nature. Ag and the Cn is in the covalent in nature. Easily it will not be broken. That's the reason attack will be from the nitrogen end. Clear? Now here alkali halide in the presence of KCN leads to get the alkali cyanide. Clear? Now here the alkali halide in the presence of the AgCN due to the presence of this covalent nature. Now the attack will be from the nitrogen, and this will give the isocyanate, this will give the cyanide. Clear? Now next ಒಂದು question ಕೊಡ್ತೀನಿ ನಿಮಗೆ. I will give one question for you. Sir, question ಏನಂದ್ರೆ this will helpful for your boards as well as your entrance exams also. Now question, now which of the following or which of these, or else you cannot, which of these is more acidic? ಈಗ ಈ ಥರ ಕ್ವಶನ್ಸ್ ಅಂತ ಕೇಳಿದಾರೆ ಅಂದರೆ ವಿಚ್ ಆಫ್ ದಿಸ್ ಈಸ್ more acidic, give the reason. Among which of these is more acidic, give the reason. One is orthonitrotoluene and the paranitrotoluene. Now among these two, which is more acidic? Orthonitrotoluene ಮತ್ತೆ paranitrotoluene, which is more acidic, and give the reason. Clear? Now ಈಗ ಈ ತರ ಕ್ವಶನ್ಸ್ ಅಂತ ಕೇಳಿದ್ರಂದ್ರೆ what do you have to say? Now first one, among the orthonitrotoluene, among the orthonitrophenol is less acidic than paranitrotoluene, than the paranitrophenol. ಅಂದ್ರೆ paranitrophenol is a more acidic than the orthonitrophenol. ಯಾಕಂದ್ರೆ in this orthonitrophenol ಅಲ್ಲಿ, among the orthonitrophenol is less acidic than the paranitrophenol. Less than the paranitrophenol due to the intramolecular hydrogen bonding, due to the intramolecular hydrogen bonding. Due to the presence of this intramolecular hydrogen bonding, orthonitrophenol is a less acidic. ಇಲ್ಲಿ ನೋಡಿ, Now acidic nature andre enu? Acidic nature andre enu? H plus should be given to the solution very fastly. H plus should be given to the very fastly. Okay, now here this is partial positive, this is a partial negative. So due to the presence of this intramolecular hydrogen bonding, due to the presence of this intramolecular hydrogen bonding, H plus will not be given very fastly to the solution. But when it comes to the para-nitrophenol, now if it is given to the H plus to the solution, let assume if it is given to the H plus to the solution, now this nitro group is a minus M as well as a minus I group. Minus M is the minus I group. Now minus M and the minus I group, it is stabilized. This carbon ion, this negative charge is more stabilized by the, this negative charge is more stabilized by the nitro group. Due to the stabilization of this nitro group, now that's the reason, due to the stabilization of this nitro group, that is, this will stabilize more fastly. But idralli you may think that sariga idralli minus M, idralli this is also minus M matte minus I. This is more nearer, sir, so this is more acidic. Don't think like that. Yakandre due to the presence of this intramolecular hydrogen bonding, this is more acidic. This hydrogen will not be given to the solution very fastly. Okay, clear? Next innondu question, same ee tarane innondu question. Which of the following is more acidic and give reason? Okay, which of the following is more acidic, give reason? Carboxylic acid with NO2. Okay. Okay. Next. Carboxylic acid at CH3. Okay. Now, ಈಗ ಈ ತರ ಕೊಟ್ಟಿದ್ದೀರಂದ್ರೆ now among these two, which is more acidic, give the reason anta kottidire. Now here the one is more acidic than the two. Ayyo sir, idralli the group attached is a plus I group alva, yakandre this will comes under the plus I group. Plus I groups will be the increase the electron density, but iga idralli charge negative charge irutte. How come this negative charge will be stabilized, sir? More it will become destabilized. Then how you are saying this is more acidic? ಈಗ ನಾನು ನಿಮಗೆ ಕ್ಲಿಯರ್ ಆಗಿ ಎಕ್ಸ್ಪ್ಲೇನ್ ಮಾಡ್ತೀನಿ. When here in the carboxylic group, in the benzoic acid, at ortho position, if any group, if bulkiness increases, if the bulkiness increases, acidic nature increases irrespective to the plus I group or minus I group or plus M or minus M. Whatever the group may be present, if the bulky group or bulkiness increases, acidic nature increases. This is due to ortho effect. This we call it as a ortho effect. Clear? Now this type of the questions they will ask in your entrance exam as well as your board exam. Clear? ಈ ತರವಂತ questions ಕೇಳಿದಿರ ಅಂದ್ರೆ you have to be very careful. Okay. ಈಗ by this we have finished what board ge 2 marks questions. ಇನ್ ದ ಒಂದೇ ವಿಡಿಯೋ ಅಲ್ಲಿ ಆಲ್ ದ ಬೋರ್ಡ್ಸ್, ಆಲ್ ದ ಕೆಮಿಸ್ಟ್ರಿ 2 ಮಾರ್ಕ್ಸ್ ಕ್ವಶನ್ಸ್ ವಿ ಹ್ಯಾವ್ ಕಂಪ್ಲೀಟೆಡ್ ಅಲ್ವಾ. ವಿ ಹ್ಯಾವ್ ಕಂಪ್ಲೀಟೆಡ್. ನಿಮಗೆ ಏನಾದರೂ ಈಗ ಡೌಟ್ ಇದೆಯಂದರೆ ಯಾವ್ದು ಕಾನ್ಸೆಪ್ಟಲ್ಲಿನೂ ಯಾವ್ದು ಕ್ವಶನಲ್ಲಿನೂ ಕಾಮೆಂಟ್ ಬಾಕ್ಸಲ್ಲಿ ಈಗ ಕಾಮೆಂಟ್ ಮಾಡಿ. ಮತ್ತು ನಾನು ಇನ್ನೊಂದು 2-3 ಕ್ವಶನ್ಸ್ ಕೊಟ್ಟಿದ್ದೇನಲ್ವಾ ನಿಮಗೆ. ಒಂದೊಂದು ಸಾರಿ ಕ್ವಶನ್ನ ಡಿಫ್ರೆಂಟ್ ಥರ ಬೇರೆ ಥರ ಅದು ಟ್ವಿಸ್ಟ್ ಮಾಡಿ ಕೊಡ್ತಾರಲ್ವ. ಈಗ ಟ್ವಿಸ್ಟ್ ಮಾಡಿ ಕೊಟ್ಟಿದ್ದೀರಂದರೆ ಯಾವ ಥರ ಹೌ ಟು ಆನ್ಸರ್ ದಟ್ ಕ್ವಶನ್ ಅಂದರೆ, ಈಗ ನಿಮಗೆ ಫಸ್ಟ್ ಏನಿರಬೇಕು, ಕಾನ್ಸೆಪ್ಟ್ ಗೊತ್ತಿರಬೇಕು. ಈಗ ಕಾನ್ಸೆಪ್ಟ್ ಗೊತ್ತಿಲ್ಲ ಅಂದರೆ ಯು ಕೆನಾಟ್ ಪ್ರಿಡಿಕ್ಟ್ ದ ಆನ್ಸರ್. ಈಗ ಇಫ್ ಯು ಹ್ಯಾವ್ ಮಗ್ಡ್ ದ ಫಸ್ಟ್ ಆರ್ಡರ್ ರಿಯಾಕ್ಷನ್ ರೆಸ್ಪೆಕ್ಟಿವ್ ಆಫ್ ದ ಈಗ ಆ ಥರ ಈಗ ನೀವು ಓದಿದ್ದೀವಂದರೆ ನಥಿಂಗ್ ಯು ವಿಲ್ ಗೆಟ್. ಈಗ ನಿಮಗೆ ಬೋರ್ಡಲ್ಲಿ ಔಟ್ ಬರಬೇಕಂದ್ರೆ ಫಸ್ಟ್ ನೀವು ಏನು ಮಾಡಬೇಕಂದ್ರೆ ಅಂಡರ್ಸ್ಟ್ಯಾಂಡ್ ದ ಕಾನ್ಸೆಪ್ಟ್. ಸರ್ ಈಗ ನಾನು ಬೆಳಗ್ಗೆಯಿಂದ ಸಾಯಂಕಾಲ ತನಕ ನಾನು ಓದ್ತಾ ಇದ್ದೀನಿ ವಿತೌಟ್ ಸೀಯಿಂಗ್ ದ ಫೋನ್ ನನಗೆ ಎಲ್ಲ ಅಂತ. ಈಗ ನೀವು ಆ ಥರ ಈಗ ನೀವು ಓದಿದ್ದೀರಂದರೆ ವೇಸ್ಟ್. ವಿತೌಟ್ ಅಂಡರ್ಸ್ಟ್ಯಾಂಡಿಂಗ್ ಇಫ್ ಯು ಹ್ಯಾವ್ ಸ್ಟಡಿಡ್ ಫ್ರಮ್ ದ ಮಾರ್ನಿಂಗ್ ಟು ಈವ್ನಿಂಗ್ ಆಲ್ಸೋ ದೆರ್ ಈಸ್ ನೋ ಯೂಸ್. ಕ್ಲಿಯರ್? ನಿಮಗೆ ಕ್ಲಿಯರ್ ಆಗಿ ನಾನು ಎಕ್ಸ್ಪ್ಲೇನ್ ಮಾಡಿದ್ದೀನಲ್ವಾ. ಈಚ್ ಆ್ಯಂಡ್ ಎವ್ರಿ ಕಾನ್ಸೆಪ್ಟ್ ಐ ವಾಸ್ ಕ್ಲಿಯರ್ಡ್ ಫಾರ್ ಯು. ನಿಮಗೆ ಏನಾದರೂ ಒಂದು ಕಾನ್ಸೆಪ್ಟ್ ಮೇಲೇನೋ ಎಲ್ಲನೂ ಇಫ್ ಯು ಆರ್ ಹ್ಯಾವಿಂಗ್ ಎನಿ ಡೌಟ್ಸ್ ಓವರ್ ದೇರ್, ಈಗ ಆಲ್ರೆಡಿ ಫಾರ್ ದ ಫಸ್ಟ್ PUC, ಫಾರ್ ದ ಫಸ್ಟ್ ಬೋರ್ಡ್, ಫಾರ್ ದ ಫಸ್ಟ್ ಇಯರ್ ಸ್ಟೂಡೆಂಟ್ಸ್ ವಿ ಹ್ಯಾವ್ ಡನ್ ದ ಬೋರ್ಡ್ ಇನ್ ದ ಲೈವ್ ಸೆಷನ್ ಅಲ್ವಾ. ಈಗ ಲೈವ್ ಸೆಷನ್ ಒನ್ಸ್ ಯು ಕ್ಯಾನ್ ಸಿ ಇಫ್ ಯು ಆರ್ ಪ್ರಿಪೇರಿಂಗ್ ಫಾರ್ ದಟ್ ಇಟ್ ವಿಲ್ ಬಿ ಹೆಲ್ಪ್ಫುಲ್ ಫಾರ್ ಯುವರ್ ಎಂಟ್ರೆನ್ಸ್ ಎಕ್ಸಾಮ್ಸ್ ಆಲ್ಸೋ. ದಿಸ್ ಈಸ್ ವಿತ್ ದ, ಈಗ ನಾನು ಕ್ವಶನ್ ತಂದಿದ್ದೇನಲ್ವಾ, ದಿಸ್ ವಿಲ್ ಬಿ ಡಿಪೆಂಡ್ ಅಪಾನ್ ಯುವರ್ ಬೋರ್ಡ್ಗೆ ಇಟ್ ವಿಲ್ ಬಿ ಹೆಲ್ಪ್ಫುಲ್. ಈಗ ಈ ಕಾನ್ಸೆಪ್ಟಿಂದ ಎಂಟ್ರೆನ್ಸ್ ಎಕ್ಸಾಮಲ್ಲಿನೂ ದೇ ಆರ್ ಆಸ್ಕಿಂಗ್ ದ ಕ್ವಶನ್ಸ್ ಆನ್ ದಿಸ್ ಕಾನ್ಸೆಪ್ಟ್ ಓನ್ಲಿ. ಕ್ಲಿಯರ್? ವಿತ್ ದಿಸ್ ಕಾನ್ಸೆಪ್ಟ್ ಓನ್ಲಿ ದೇ ಆರ್ ಆಸ್ಕಿಂಗ್ ಇನ್ ದ ಎಂಟ್ರೆನ್ಸ್ ಎಕ್ಸಾಮ್ ಆಲ್ಸೋ ದೇ ಆರ್ ಆಸ್ಕಿಂಗ್ ದ ಕ್ವಶನ್ಸ್ ಇನ್ ಯುವರ್ KCT. ಈಗ KCT ಅಲ್ಲಿನೂ ಮತ್ತು ನೀಟಲ್ಲಿನೂ JE ಅಲ್ಲಿನೂ. ಓಕೆ, ಸರಿ ಆಯ್ತಲ್ವಾ. ಈಗ ನಿಮಗೆ ಏನಾದರೂ ಒಂದು ಕಾನ್ಸೆಪ್ಟ್ ಮೇಲೆ ಏನಾದರೂ ಡೌಟ್ಸ್ ಇದೆಯಾ ಅಂದರೆ ಏನು ಮಾಡಬೇಕು, ಕಾಮೆಂಟ್ ಬಾಕ್ಸಲ್ಲಿ ಕಾಮೆಂಟ್ ಮಾಡಬೇಕು. ಈಗ ನಾನು ಆನ್ಸರ್ಸ್ ಆಲ್ಸೋ ಕೊಟ್ಟಿದ್ದೀನಲ್ವ, ಕ್ವಶನ್ಸ್ ಆಲ್ಸೋ ಕೊಟ್ಟಿದ್ದೀನಲ್ವ. ಈಗ ಯಾವ ಥರ ಡಿಫ್ರೆಂಟ್ ಥರ ಕ್ವಶನ್ಸ್ ಕೇಳಿದ್ದೀರಂದರೆ ನಾವು 2-3 ಕ್ವಶನ್ಸ್ ಏನೋ ಕೊಟ್ಟಿದ್ದೀನಿ ನಾನು. ದಟ್ ಆನ್ಸರ್ಸ್ನ ನೀವು ಕಾಮೆಂಟ್ ಬಾಕ್ಸಲ್ಲಿ ಕಾಮೆಂಟ್ ಮಾಡಿ. ಯಾಕಂದರೆ ಈಗ ನೀವು ಕಾಮೆಂಟ್ ಮಾಡಿದ್ದೀವಿ ಅಂದರೆ ನನಗೂ ಇಂಟ್ರೆಸ್ಟ್ ಆಗುತ್ತೆ. ಯಾಕಂದರೆ ಈಗ ನಮ್ಮ ಮಕ್ಕಳು, ನಮ್ಮ ಸ್ಟೂಡೆಂಟ್ಸ್, ದೇ ಆರ್ ಸ್ಟಡಿಂಗ್, ದೇ ಆರ್ ಕಾಮೆಂಟಿಂಗ್ ಓವರ್ ದೇರ್, ಸೊ ದಟ್ ಮೋರ್ ಐ ಹ್ಯಾವ್ ಟು ಗಿವ್ ಅಂತ ನಾನು ಅದನ್ನು ಕೊಡ್ತೇನೆ. ಓಕೆ, ಬಾಯ್, ಆಲ್ ದ ಬೆಸ್ಟ್. ಆ್ಯಂಡ್ ಯು ಹ್ಯಾವ್ ಟು get 70 out of 70 in your boards. And once if you got the 70 out of the 70 in your boards, once you comment over in the comment box, so that by seeing that we will be very happy. Okay, bye, see you in the next video. Right.